For most games, you need to get input from the player. Unity has two standard input systems that it supports, including its original input manager and the newer input system package. There are also third-party input systems that you can purchase and use, such as Rewired. For this project, we'll use Unity's new input system package. But when you start a new Unity project, it defaults to the old input manager. To switch to the new input system, you need to go through a few steps. The first thing that we need to do is import Unity's new input system package. To do this, open the Window menu and go to Package Manager. Then under Packages in the top left, select Unity Registry. We could then search for the name of the package, which in this case starts with input, and you can see the input system comes up right here, and it shows the current version and some details about it. I'm just going to go ahead and click Install, and this will go through the process of installing the package into my project. Once the installation is complete, you should get a pop-up warning about switching to the new input system. Of course, we want to do this, so I'm going to go ahead and click Yes, and then the Unity editor will restart. Once Unity restarts, back in the package manager, I can switch from packages in the Unity registry back to packages in my project. And you can see all of the packages that are in my project, and you should now see the input system is one of those packages. And we can go ahead and close the package manager window. And we have the new input system package in our project. You can open up packages and you should see the input system here as well. I'll go ahead and close that. We have provided you with a custom asset package to help you build your project. In fact, we provided everything you need for the tutorial portion of this assignment. Later on, you can add your own assets in the modifications part of the assignment. We provided the assets within what Unity calls a Unity Asset Package. This is a single file that bundles up potentially many game assets, much like a zip archive. But the Unity Asset Packages have the .unity package file extension, and it is commonly used to transfer game assets from one Unity project to another. You can create your own Unity Assets package by selecting Assets in a Unity project and going to the Assets menu and choosing to Export Package, and then clicking Export to export those assets to a .unity package file. But for now, let's import the assets. So the first step is to download the asset package from the link we provided in the assignment. And it likely comes down into the Downloads folder. The link that we provided to you is actually a zip file. So the first thing that we need to do is extract the contents of that file. If you're on Windows, you can simply right-click on the file and choose Extract All. So here's the 2D shooter assets. Let me right-click and choose Extract All. This will ask where we want to store it. I'm just going to put it right there in the downloads as well and extract that. Now, if you're on a Mac, when you first download it, it likely auto-extracts the file for you. If not, you can just double-click on it and it will extract it for you in the same location. And you can see here, we've got our 2D Shooter Assets Unity package. And then let's go back to Unity. And we've got our project open, of course. And the next thing that we want to do is go to the Assets menu and go down to Import Package and select Custom Package. And I'll navigate to my Downloads folder, and I should have the 2D Shooter Assets folder there. If I go inside of that, it should have the 2D Shooter Assets Unity package that we just extracted. So let me select that and open it. This will open the Import Unity Package window, and this shows all of the folders and files that are part of that package. And we can select or deselect things that we want to import into our package. Now, of course, we want to select all, so if I click the All button, it should select everything in the package, which is generally the default. And I'm going to go ahead and click Import to import all those assets into our package. Once the import is complete, you should have several new folders within your assets within the Project tab. And these folders contain many wonderful assets for us to use to build our game. In this video, we're going to set up the visual representation of the player. The first thing that we're going to do is ditch the sample scene. So if you open the scenes folder, notice that we have a sample scene provided to us. This was created when we created our original project using the 2D core template. So I'm going to go ahead and right click on this and select delete to get rid of that. And then I'm going to create a new scene. One little shortcut to put something right in a folder is we can right click on the folder itself, go down to create, and create a scene. And this creates that right in the folder. I'm going to name this scene level 1 because it's going to be my level 1 scene. And then let's go ahead and open that scene by double clicking on it. And we don't want to save the previous sample scene that we have open here. So I'll say don't save that since we just deleted it. And lastly, I like to rename my scenes folder like we did in the solar system project. So let me right click on that and rename. And I'm going to just add an underscore in front of that. And that brings it right to the top. So when everything is sorted alphabetically, the underscore scenes is the first thing that we see. So we can quickly see our scenes at the top of assets and switch between them once we have multiple scenes. Okay, now that we have this level 1 scene, we can start building the player in it. The first step to this is putting together the player's representation. If we navigate within the assets and open the art folder and then open the player folder, you can see we have a player sprites asset. And I'm going to click on that and we can look at the various import settings. Notice it's set, the texture type is set to sprite. And if we scroll down, remember there's a preview at the bottom. I could pull this up and get a preview. And notice that this one 2D asset actually has sort of 3 different versions of a ship in it. And each of these versions ultimately will represent a sprite. And because the texture type is set at sprite, it has already done that for us. If you click the little cascade here, you can see that we actually have 3 sprites. And if I click on them over in the inspector, we can actually see each of these sprites. And you can see they're roughly the same. There's just some lights that light up and so forth. So what I'm going to do is I'm going to select the first sprite in the list, and then I'm going to hold down the Shift key and select the last sprite. And this will then select all 3 sprites at the same time. And with all 3 selected, I'm going to drag them into either the hierarchy or the scene. I'll drop it here in the hierarchy. And you will get a File Explorer window prompting you to save a new animation, which has been created from that operation. So in the File Explorer, I'm going to navigate within Art, and we've already created an animation folder for this. So let me go in that, and then we have a player folder. So let me go into that. And then we actually need to name this animation. I'm going to call this player idle and hit save. Okay, and that actually created the file within animations, player, and you can see the player idle animation there. Now we can actually see a second file here called player sprites _0. This is actually what Unity calls an animation controller. The name's a little confusing, so let me actually click on it and rename it. And I'm going to rename it as just player. Notice in the hierarchy, we also created a game object. And if I select that, it also has sort of a cryptic name. So I'm going to rename it. So once again, we can right click and select rename. And I'm going to rename this as player. You could also rename in the inspector at any time. And you can also click on something and move the mouse down slightly. And then we get our insertion point and rename that way. So there's multiple ways of doing these things. Okay, we've got our player game object created. Let's go ahead and save the scene. So on Windows, that would be Control S. On the Mac, it would be Command S. Now let's take a moment to look at the player game object. So go ahead and select that. And let's go through some of the components on it so that we understand them a bit. The first component of a game object is always the transform component. It includes the position, the rotation, and the scale of the game object. The second component on the player is actually a sprite renderer component, which is important because it determines what sprite is displayed and how it's displayed. So notice the first property is the actual sprite. If you tap on these things that are already targeted, it will select it over in your project view. So that's kind of a quick way to see what it is. And of course, once I did that, I can select it over here and then get the preview in the inspector. Let me go back to the player object. The third component on this game object is the animator component. The first property specifies the animator controller we just created. So we rename that as player. Now remember, once again, you can always click on the little question mark icon at the top of any of these components that opens the reference, the documentation, and you could read more about, the various settings and what they do. Okay, without further ado, let's just play our scene. So let me go and hit the play button to go into play mode. And if you look closely in the game view, you'll be able to see that our sprite is actually animated. You can actually increase the scale if you want, and you can see it's cycling through those 3 frames, those 3 sprites, to create this simple animation. Let's go ahead and exit play mode by hitting the play button again. Now Unity provides various animation editing tools. So if we go to Window and go down to Animation, we can pick the Animation window. This opens that window, which has sort of lots of different UI in it. And one thing that we can do is we can actually dock these windows within our editor. So, whenever you're going to be using a tool often, rather than have it be a floating window, it's nice to kind of dock it. So I like to put the animation window docked down here. So if I just drag on the tab and then let it go, it makes a new tab down in this panel. So I can switch between now the game view tab and the animation tab. And if you're not already selected, make sure to click on the player. So we're actually looking at the animation on the player. You can see that the player idle animation is set here. If there were multiple animations, we would see all of them if we click this little drop down menu, and we could create a new one here. But let's just stick on player idle for now. Now, if you look at the first row here, it says player sprite. And if I click this little drop down, this will actually show the sprite at each keyframe out here in the timeline. Now, if we hit play here in the animation window, you can see it actually loop over those frames. And if you look in the scene view and zoom in, you could actually tell that it is actually looping through each of those frames. Let me go ahead and stop this. We'll come back and look at the animation interface more later. We can do a lot of things, add keyframes, modify things, add additional properties beyond the sprite that change over time, for example. But for now, let's go ahead and go to Window once again and go down to Animation and pick the second thing in the list, which is the Animator. So, it's common to confuse animation, which is this window that we just looked at, and the Animator. So let me choose Animator. This will open up the animator window, which I actually already have docked. If you don't, it might come up as a floating window like this. And just like we did with the animation window, you can grab the tab and drag it and drop it. I like to, drop it in this view above, parallel to the scene view. So I can switch between the scene view and the animator. And this way I could kind of have the animator and the animation window open at the same time, because you often use these in parallel. Now the animator window shows a state diagram of the last selected animator controller. In our current case, this would be the player controller. Each state of the animation is represented by these orange boxes. And currently we only have one state. You can actually use your scroll wheel to zoom in, zoom out. So let me do that. And you can use, click the center scroll wheel to actually pan around this. Okay, so we can see that one state. You can click and drag these around to reorganize. Like I said, currently we only have one animation, the player idle animation clip that we just looked at in the animation view down below. Notice there's an arrow from the entry rectangle to the player idle state. This means that when the animator starts, it transitions immediately to the player idle state. And if we actually hit play up here, you can see the animator demonstrate what is happening as the game plays. Right now, it is very simple because we just have the one player idle state, and you can see the sort of looping through that state. Of course, while these are playing, you can switch back and forth between the tabs. They're all fully functional. And once again, we'd have to select the player to see this clip. When the game is playing, it doesn't actually play the animation down here. That would be a separate operation within that window. But if I go back to animator, once again, we can see that sort of transition. Now, the animator is another interface we'll discuss much more later. For now, let's go ahead and stop and save our scene. In this video, we're going to start setting up the controls for our player and take our first look at the console window. Back in our project once again, we have our level 1 scene open. I'm going to switch to the scene view once again and the game view. Our player is visible in the scene, but this is a game and we want it to be interactive. Interactivity is created in Unity using pieces of code called scripts. These scripts are written in the C# programming language. We aren't going to make you write any scripts just yet. Instead, we've provided you with several scripts to get started. If we navigate in our assets to the scripts folder, so let me go ahead and close that and open scripts and look into the player subfolder, you will see a controller script here. And we want to attach this controller script to our player game object, and we can do that in several ways. One of them is to just drag and drop that onto the player. And if we click on the player now, we can see we've got a new component attached, the controller script component. And we can see it has a bunch of different settings for us to mess with. Now the controller script isn't, set up completely yet, but if we enter play mode, we can see what happens. Now the player sort of flips there, but it doesn't actually move in response to any input. Neither the WASD keys, nor the arrow keys, nor moving the mouse around. But eventually we'll set it up to do this. Now, if you're a programmer, your first instinct might be to open the script and start reading. But fortunately for us, we don't have to do that just yet. Most of the scripts that we provided will tell you what's wrong through descriptive warnings and errors in what's called the console window in Unity. Now, you can open the console window in a number of ways under the window menu here. But the common, most fastest way is using the very bottom of the Unity interface. You can see this message here in red. This is actually the last message in the console window. And if I tap on this, it actually brings up the console window. The console window has a lot of options to help you in debugging what is going wrong. On the top of the interface, there are several toggles for various output types that get sent to the console window. They're over here. From left to right, you can see the first one is our debug output. Currently, it's 0. There's no debug output. Now, these would be statements that Unity's internal debugging would send to the console. The second is warnings. You can see there's one warning currently. This tells us any issues that probably won't crash the game, but they're warnings for us, and we may want to fix them if we need to. And the last is the errors. And you can see I've got lots of errors here, 999 plus, which are usually issues that will prevent your game from running properly. So these are probably the most important ones when we see them pop up in the console window. Now on the top left is a clear button. You can see we've got a lot of things here. If I clear it, it restarts. And you can see since I'm playing, it's constantly generating messages here. Let me actually stop playing for a moment. And you can see now when I clear it, we don't get new messages here. Now, if you click the little cascade drop down here, this will bring up a menu where you can see we've got clear on play, which basically means when we hit the play button, it will actually clear it, clear on build and clear on recompile. I generally like to leave these things turned on, but you can adjust them if you so choose. The next option is collapse. Remember we had 999 plus messages before. Collapse will collapse identical entries into one. So let me go ahead and turn this on and then hit play again. Now you can see that we don't get lots and lots and lots of messages here in the console window. We just have 2 messages, and this number over here tells you how many times that error occurred. So you can see we're getting lots of them, but it doesn't mess up our display. Now after that is the error on pause button, which pauses playback whenever there's an error. If I actually tap this, it's going to immediately pause the game because I'm getting errors continually. Now I typically personally leave this off unless I want to be very aware of when an error occurs. I like to always kind of pay attention to the console window, either have it up or look at the bottom line here to see if something pops up. But if you kind of miss those things, you might want to click error on pause, which basically, once again, whenever there's an error, one of these red indications, it will actually pause the game. So it really draws attention to like, hey, an error just happened. And the last button here in the console window is the editor. Now we're going to just ignore this for now, but you can explore it on your own time if you so choose. Now, if we clear the console window once again and, stop from playing, so everything is cleared, let me go ahead and hit play again. And let's actually look at the console log. Now, the first thing that we have is a warning. When debugging, we almost always want to look at what's first or what's on top. This is because issues and errors tend to cascade, meaning that the first problem often causes additional problems down the road. So if I actually click on this, notice that we get more details on it down below. If you read the warning, it says an input action does not have a binding set. Make sure that each input action has a binding set or the controller will not work. This warning is generated by the controller script. You can see that right here. At an asset scripts player controller.cs. So that is the controller script that we just attached to the player. And it actually gives a line number as well, line 106. So once again, this is a great way to quickly find where there's a warning or where there's an error. You can actually click on this and it will open the script and bring you to that line number so you can help diagnose that. Now we're not actually going to do that right now. We're just going to kind of look at this. Now if we look at the next error, once again, we can read about it. We can read where it occurs and so forth. You can see that it occurs, later on in that script at line 166. And this is sort of a cascade where, it causes additional problems. Now, once again, often when we're debugging, we want to look at the first thing because these latter issues in this case are actually caused by the first issue. In this case, we see the warning and we know what's wrong. We need to set up the input actions or the bindings for our script. This is the topic of our next video. But for now, I'm going to go ahead and stop playing and I'll turn off the error on pause option and close the console window. Once again, you can always get back to it by clicking down here. And I'm going to go ahead and save my scene. In this video, we're going to continue setting up the controls for our player, including setting up the input actions and input bindings. So go ahead and select your player game object and find the attached controller component, should be at the bottom in the inspector. Under the controller component, there is an input actions and controls section header, which has two input actions under it, one called move action and one called look action. So these are the controls that we want on our player, moving and looking. Now, if we click the little plus on the right side of the move actions, we do that to add a new binding to control movement. So let me click on that. And I want to select the up, down, left, right composite. This will let us provide a set of bindings which provide horizontal and vertical input. Now you can see it named this 2D vector and we can rename it right away. I'm going to rename this as WASD or WASD because these are going to be our WASD controls for our ship. Now we can start assigning key bindings by double clicking on these. Let me double click on up. This will bring up two sets of settings including bindings and processors. The one we care about right now is the first one, the binding. And if we click the drop down right by path, we can specify the path to the binding. Now we have several options for setting bindings. You can see things are organized by type, for example, keyboard. We can also search for things or we can listen. Now we'll actually kind of explore each of these as we go, but for purposes of example, let's click on listen. And now Unity is basically listening for us to do something, and I'm going to press on the keyboard the W key. And you can see it pulls up a list of things, either W key or any key. And I'm going to go ahead and select W. This will bind the up action to the W key. Okay, and if I select on down, you can see the up is set to the W key. So now let me double click on down. It brings up the same interface where we see bindings there at the top. And I'll click the drop down for path. And once again, we can click on listen and press the S key. This will show various options, and I'm going to pick S as the action. And that gets set there in the interface. Now for the left, let's double click on that. And once again, click the down arrow for path. And this time I'm going to just use the search bar here, and I'll type the A key for left. And notice all the different options. You can see, A buttons on different types of controllers. But one of the options here is the A on the keyboard. And that's what I want. So I'll go ahead and select that. And then let me double click on right. And once again, we can click the down arrow. And the third method is we can just search through these. So I can click on keyboard and, pick by location of key. Now, if I scroll down, I can select the D, and notice it sets it to the D on the keyboard. And we've got our WASD set up, W for up, S for down, A for left, and D for right. So we've got our control inputs binded to various actions here for our move action. Now, if we enter play mode by hitting the play button, we now have our move action set up. So here in my game view, I'm going to go ahead and scale back to 1x. And if I hit W, notice I go up, S to go down. If I hit A or D, I can now have control over the player. And once again, we can see we're getting an error here on the look action. If I click on that, we can look at the console window because we dealt with the move action, but not yet the look action. So let's go ahead and close this and stop playing. Before further ado, let's just save our scene so we don't lose any work if something happens. Now we must assign a binding for our look action. So let's go down on the player and look at the look action. And just like we did before, we'll hit the plus key. And we're going to select add binding. And we'll double click on this to open up the same sort of interface. And under binding, we can click the drop down. And I'm going to use the search bar for this. So for looking, I want to use the mouse's position. So as I move the mouse around, it's going to look at the position of, basically the mouse pointer. So let me start by typing mouse space position. And you can see that I eventually get various options here. The first being the position of the mouse. And I'm going to go ahead and select that. And that sets the binding here. And let's go ahead and hit play mode once again. And notice now when I move my mouse around, my player is actually looking at the mouse pointer. And I can, once again use WASD. And in combination now, I've got a controllable ship. I'm going to go ahead and exit play mode and save my scene once again. It's always good practice to save your scene incrementally as you go along and make changes. And with that, the player controller component is now set up. Notice the last time that I played, I did not get any errors in my console window. In this video, we'll set up the player to use 2D physics to collide and take damage. As a brief review, in Unity, there are 3 things we typically have on a game object when we wanted to have physics-based interactions, such as collisions. The first thing we need is for the game object to have a collider component. Collider components define the shape of an object for purposes of physical collisions, as shown here as the green outline around the sprite. A collider, which is not visible in the game, need not be the exact same shape as the visual representation of the object. And in fact, a rough approximation is often more efficient and indistinguishable by the player when playing the game. You can have a collider alone on a game object, but you often also want to combine a collider with a rigid body component. A rigid body tells Unity that the game object should interact with the physics engine. That is, the game object has mass and should react to forces and collisions in a realistic manner. With a rigid body component, you can have a game object be affected by the forces of gravity, for example. And lastly, we often want a custom script component that determines what happens when the collision occurs, such as health being lost, and perhaps a visual or audio effect playing. Back in our level 1 scene, we've got our player moving using player input, but there's more that we want our player to do than just move and look around. We want our player to be able to take damage and lose the game. To do this, we're going to need to add a few more things to our player and the scene. The first thing that we want to do is actually give our player health. So if we navigate under scripts, once again, there is a folder called health and damage. Let me open that, and you can see two scripts, one for damage and one for health. I'm going to select that health script and drag and drop it on my player game object over here in the hierarchy. Now, of course, if I click on the player, I should now have a new component. They generally add at the bottom. So you can see my health script component. Under the health script component on the player, we have several different settings. The first is the team settings. And all of these things, if you roll over them, it will give you a tooltip to further describe it. But the team settings is the setting that works with the damage script to prevent friendly fire. Basically, health will not take damage from anyone with the same team ID. For our purposes, we're just going to leave this as team ID 0. Now there's various health settings. The first is the default health, which is how much health your player starts with. And then there's maximum health, which is the maximum amount of health the player is allowed to take during the game. And then the current health, where the player currently is at, and that kind of is a nice debugging thing. As your game is playing, you can look at the current health. There's an invincibility time, which is how long your player is invincible after getting damaged. And this is in seconds. So we have 3 seconds of invisibility, and we could change that. And then there is a is always invincible checkbox. So if we want the player to always be invincible, we can check that. And the next settings are our live settings. So the first thing is to use lives or not. Right now it's not checked, so we're not using lives. But we actually want to use lives for this game. So I'm going to go ahead and check this box to use lives. And then the next thing is the current lives, the current number of lives, how many lives the player currently has, which is set at 3. And then the max number of lives, maybe you have a power up in the game and you can earn additional lives and you can set what the max is. And currently that's set at 5. And I'm just going to go with the defaults now. You can always set those things later. And the last set of properties here in our health component are effects and polish. So the first thing is a death effect. And we can actually specify a game object that will spawn when the player dies. And then there's a hit effect, which is the same thing, a game object that is created when a player takes damage. So let's go ahead and set them up right now. So within our assets, let's find the prefabs subfolder. And within that, there is an effects folder. And then there is a player effects. We tried to organize these, to be logical so you can quickly find things. It might take you a little while to figure out how we organize them, but there's a lot here, so we tried to organize them so it's not just a huge list of assets. So you can see within this subfolder, we have a player death prefab. And notice if you click on this, it actually changes the inspector, to be that. And sometimes when you're working in Unity, you accidentally click and you're like, oh, wait, I wanted this over here. I wanted to see the player object. Now, one thing you can do is you can actually lock the inspector. So see this little lock at the top? If I click that, it locks the inspector to the player. Okay, so if I click over here, notice the inspector doesn't change. Okay, so this is a super nice feature to do, but just realize that it is locked. If I wanted to actually look at that, I would have to unlock it. Then it's going to change the inspector to be whatever selected. So let me go back to the player, lock the inspector for a moment, and then I'm going to drag and drop the player death prefab, player death effect prefab onto the death effect. So I can do that. And you could actually do this unlocked, if you just click and drag. But if you click and then click and drag, it will change the inspector. Okay. So obviously for the hit effect, we want to drag the player hit effect onto the hit effect property. Okay, I'll unlock the inspector so I don't get confused later. And I've got those two things set now. And once again, I'll save the scene incrementally as we go here. Now to test this, we need something that can actually deal damage to the player. So let's navigate once again into our prefabs. And I do recommend you kind of open and close things as you go to keep things, you know, kind of organized so we don't have tons of things here that we're looking at. So within prefabs, we have enemies. And then within the enemies, we have individual enemies. Let me open that. And we have a stationary shooter. Let me open that. And one of the prefabs in here is a straight shooter. So I'm going to actually drag the straight shooter prefab into my scene. And you can see that it looks like a little enemy here. And I'll, go ahead and drop it. And of course, I can zoom out a little bit in my scene. And, use the move tool and move it up a little bit, to give a little space between the player and the enemy. And of course, doing all this created that straight shooter game object. And, it is based on a prefab. So you can see it's the blue box rather than the empty box. And whenever there's a prefab, there's actually a little arrow here, which we could click on to go into the prefab edit mode where we're just editing the actual prefab. We don't actually want to do that now, but I just wanted to remind you of that functionality. So let me back out to my scene level. So now that we have an enemy in our scene, let's go ahead and hit play. And you can see and hear the enemy. It's moving around, it's shooting, and bullets are going at my player. But notice if we move in line of fire, we don't actually get hit yet. So things aren't completely set up. So let me go ahead and exit play mode. Now this is because we haven't set up any collision detection or physics for our player yet. So the projectile cannot hit the player and affect that health script that we attached to the player. There are two different types of physics engines in Unity. One is for 2D and one is for 3D. This distinction is important because the two do not interact with each other. For this project, make sure that you use the 2D version of the physics components, since this is a 2D game. Now let's click on our player game object, and then in the inspector, if we scroll to the very bottom, go ahead and click Add Component, and we can see an organized list of possible components. Go down to Physics 2D. Once again, this is the 2D physics. Notice there's one that doesn't have 2D. These are for 3D. So let me go into Physics 2D, and I'm going to select, toward the bottom, there is a rigid body 2D. Let me add that component. So with a rigid body on this object, let me just hit play to go into play mode. Now you can see the player immediately fell because a rigid body, one of the properties is giving gravity to things. So let me stop this. And let's look back in our inspector at the rigid body. And one of the things is the gravity scale. And I'm going to go ahead and change that from 1 to 0, which basically is a way of effectively turning off gravity. Let's also give the player's rigid body 2D a few more setting changes to make it work better. Notice where it says collision detection. It's currently set to discrete. And I want to change this to continuous because this is more of a Twitch game. I want to continually check for collisions all the time. So discrete is kind of less often. So let me choose continuous. This will make the collision detection happen more smoothly. And let me change the sleep mode from stay awake to never sleep. Changing to never sleep means that the rigid body will always be active, which we want for our player, just to make sure its collisions always happen, once again, in a Twitch-style game like this. Let's go ahead and enter play mode once again. Now, our player is using physics without gravity, but the projectile of the enemy still phases through the player. Now, why is this? Our rigid body 2D is only part of the physics puzzle. The other part is a collider, or a 2D collider in this case. Typically for physics operations, such as collisions, we need both a rigid body and a collider component on the game object. Let's go ahead and exit play mode so we don't have that shooting going on continually. Now we can see an example of a 2D collider if we click on our enemy. we can see that it has both a rigid body 2D component and a collider component. In this case, a polygon collider. Now within the scene view, we can actually see the collider on this object. It's actually the little green outline that you see over the body of the enemy player. Now we want to have the same thing set up on our player. So if we click on the player game object, and once again go to the very bottom in the inspector and click Add Component, we're going to go into Physics 2D once again, and we want the Polygon Collider 2D. Okay, so I'll select Polygon Collider 2D. It adds that component. Now in the scene view, the Polygon Collider tries to match itself to the sprite based on, basically the transparency values of that sprite. You can see the green outline here. Now, obviously, in this case, it didn't match up perfectly. If you look back at the Polygon Collider component in the inspector, where it says Edit Collider, we can actually click this little button here, where it says Edit the Collider Geometry. And when you do that, we can now go back to the scene view, and notice when I'm dragging around, I get these little anchor points. And I can actually drag these in to adjust the collider on this object to be a little more in line with the actual shape of the ship. So go ahead and do that. You probably want to look something like this, that roughly polygon that roughly matches the outline of the ship. And when you're done, you can go back to the Edit Collider and click that button again to go out of edit mode. Once you are satisfied with that, go ahead and hit play again and try to get hit by the enemy projectile. You can see I'm actually getting hit. If I move away and it shoots, it misses it. If I come back and get hit, I get hit. And there is a 3-second invincibility once again. So if you're not hit for 3 seconds, you're okay. And I actually died because it killed 3 of my lives, so my player went away. Let me go ahead and stop that. Now remember, when adding game objects that you want to have collisions upon, you typically need both a rigid body and a collider component upon them. Let's go ahead and save our scene for now. In this video, we'll create our 2D Unity project in Unity Hub. The first step is to open Unity Hub and select Projects on the left-hand side, then click the New Project button. In the middle, you can set the version of Unity that you want to use. Make sure to pick the version specified in the course. In the middle, we can select our template. Since this is a 2D project, we want to select the 2D core template. On the left-hand side, we can set our project name here. I'm going to go ahead and call this 2D Shooter. Before we click the Create button, let's see where your files for the project will be saved. If you click on the little folder icon here by location, Unity will open a window that allows you to browse through your file system. Select the location where you want to save your project. If you recall, in the solar system project, I created a Unity projects folder within my user folder to store my Unity projects. I'll select this folder. If you don't already have it, you can create your own Unity projects folder using the new folder button here on Windows, and there's an equivalent button on the Mac. Remember not to place your Unity projects within a cloud syncing folder, such as your Documents folder or on the desktop. And with those things set, I'll go ahead and click Create Project. Unity will now create a new empty 2D project for us based on that 2D core template, which can sometimes take some time to do. So we'll fast forward to this. Once your project has been created, it should open in the version of Unity that you specified. You can see that in the title up here at the top of my window. In the solar system project, we set up a favorite layout, which I have currently selected. Unity generally will remember your previous layout that you've selected. If your editor does not look like mine, you may want to choose your favorite layout if you did that in the previous project in the layout dropdown right here. If you didn't create a favorite layout, the one that I'm using is the 2x3 layout. and then going to the project tab and selecting the ... and switching to a one column layout. And that's essentially the same thing that I saved as my favorite. So if you want to save that, you can go ahead and click Save Layout and then save it as a favorite layout if you don't already have that done. In this project, you'll continue to learn about game development in Unity by creating your very own 2D shooter.
2D shooters have been around for a long time. Space War, one of the very earliest video games, centered around two ships shooting at each other. Other popular early shooter games include Space Invaders, Asteroids, Defender, Galaga, and Berserk. 2D shooters are usually viewed from a top-down or side-view perspective, and players must use ranged weapons to take action at a distance. The player's avatar is typically a vehicle or character under constant attack. Thus, the player's goal is to shoot as quickly as possible at anything that moves or threatens them. The 2D shooter genre or subgenre has lasted the test of time. 2D shooters are still being made today commercially and is a favorite among the indie game developer crowd. In this project, you'll get your chance to create your very own 2D shooter game. The concepts we will learn includes creating 2D games in Unity, working with 2D sprites, creating 2D animations, implementing typical 2D shooter mechanics, and using Unity prefabs. Other concepts include creating a complete game loop, creating user interface elements that work across multiple resolutions and aspect ratios, Unity best practices, as well as Unity tips and techniques to help with your game development workflow. You can view these lesson videos as a tutorial. During the lessons, do what works best for you. You can follow along with the videos and create while you watch. Or you can watch a bit of the video, then pause the video, try to reproduce what you saw, and then continue. Or you can watch the entire video, then reproduce it, and rewatch any parts of the video that you had trouble with. Or some combination of the above. Once again, do what works best for you. While your personal goals may be focused on a specific game development role, such as an artist, designer, or programmer, in this project you will learn and apply concepts across art, design, and programming. This holistic approach will grow your knowledge within your chosen discipline while increasing your understanding in how art, design, and code come together to make a game. Whether you ultimately will be creating games by yourself or on a team, you will be a better game developer because of this approach. We will be covering many concepts and practical skills as we go. Try to not just replicate what you see, but really try to understand what you are doing. Learn the process, the terminology, and the concepts. That way, you will truly build your knowledge and skills as a result of doing the project, not just have rote learning. And lastly, in addition to watching the videos, also make sure to read the assignment. You will need to use both the videos and the assignment write-up to complete the project. I encourage you to read the assignment now, before we dive into the videos, if you have not done so already. Then read it again at the end of the videos to make sure you finish up your project correctly.
In the following videos, we'll run through the tutorial, and you will begin making the game. While making games is sometimes challenging, remember, we're making games, so make sure you're having fun. Take the time to play and experiment with ideas. Explore the Unity documentation, get inspiration from other games, and discuss ideas with other students along the way. Let's begin. The player can now die, but it isn't particularly fun to only get shot at. So now we're going to give the player the ability to shoot back. So back in our level 1 scene, if you go to the scripts folder once again and look at shooting projectiles, you can see that we have a shooting controller script. And I'm going to go ahead and drag and drop that on my player, which of course, if I click on the player, I get a new component at the bottom of the inspector called shooting controller. Now the shooting controller script component has various settings that we want to look at. The first setting is the projectile prefab, which is where we will put our projectile that we want to actually fire. We'll do that in a moment. There's also a projectile holder, which is an optional game object that we can create to hold projectiles in the scene to keep the hierarchy clean. We'll actually use that as well in a moment. The next option is player controlled checkbox. This basically says, is shooting player controlled or is it not, like in the case of enemies. This is, of course, going to be player controlled, so I want to turn that on. And then the next option is, what is the actual fire action? So this, once again, is the binding of the action to the controls. And we'll set that up here in a moment. But just to finish out looking at the settings, you can see there is a fire rate, which is how fast the projectiles are fired. If you wanted to fire slower, you would increase that number. And then a projectile spread, which is how far apart the projectiles are potentially fired from each other. And then the very last thing is a fire effect, which is a game object that is spawned when we actually fire. So we're going to actually set up most of these things, starting with the projectile. So once again, we've created a lot of these things for you, and you can, of course, modify them later. But within prefabs, we have a projectiles subfolder. So go ahead and open that. And notice there is a player projectiles folder within that. And here is our player projectile prefab. Now, if we drag and drop that on the projectile prefab spot, that will specify that. The next thing that we want to do is set up our fire action binding. So let me go ahead and click plus here. And I'll click add binding. So I can specify a binding here. And if we double click on no binding, it opens up our ability to set a binding. And I'm going to click the little drop down under path as we've done before, and go ahead and click on mouse and look at the various options. I want to bind this to the left mouse button. So let me go ahead and select that. And you can see we've got that binding set. And let's go ahead and enter play mode and see what we've got. Okay, my enemy's kind of close to me, so it generally hits me before I can move out of its way. We can resolve that later. But notice now I can, once again move and I can look. And if I click the left mouse button, I can actually fire. And you can actually even aim at the enemy and destroy the enemy. Now, one thing to notice is we get a lot of game objects within our scene view as we're shooting. So notice all of these player projectiles that are being created from that prefab, and eventually they destroy themselves and go away. Let me go ahead and exit the play mode. And we want to create a projectile holder object. So I'm going to go ahead and in the hierarchy, I can click the little plus. You can also right click kind of just out in open space within the hierarchy, and it also brings up the ability to create things. So either way. And I'm going to go ahead and create an empty game object. And I'm going to name this my projectile holder. And if we go back to the player, remember one of the settings was the projectile holder. And I can just drag and drop this on that property. And now when I play, when I'm shooting, notice that we don't see all those shooting projectiles. They're actually inside the projectile holder. So if I click the little cascade to show it, you can see them there. Okay? So it's kind of a way to hide all of those things within my hierarchy at the top level so it doesn't get, super filled with things that are spawning out in the world. Okay, let's go ahead and stop. Now, when we fire lots of projectiles, we don't completely flood our hierarchy with them. Instead, they get organized under our projectile holder game object. Let's go ahead and save our scene. That's almost everything set up for shooting, except we would like an effect to be created when we fire. So let's build one of those ourselves from our assets, rather than use a prefab for that. So just like before, I want to create an empty game object to start. So I'll right click and choose create empty. And I'm going to name this my player fire effect. And we created the game object. Right now it only has a transform component. And I want to add a few other components based on scripts that we provided. So let me click the add component. And one way to find scripts is to go down to scripts. And this is going to show, kind of all the scripts alphabetical in the project. If you know the name of the script, you can just type it up in the search bar. So I'm going to start typing timed. And we have a script called timed object destroyer. I'm going to select that. This script will destroy whatever game object is attached to it after a few seconds. So our hierarchy doesn't get overwhelmed and our game doesn't get overwhelmed tracking, potentially millions of game objects. So you can see one of the settings is the lifetime of the object, and this is currently set at 5 seconds. So after 5 seconds, it's going to destroy this game object. And I'll just stick with the default for now. Now I want to add one additional component. Let me click on add, and I want to add an audio source. So it actually plays a sound, when the user fires a projectile. So let me start by typing audio. And once again, we're searching through things, and we can see there's an audio source component, which we've used in the past. And once again, the audio source component has various settings on it. Once again, you could always click the little question mark to look at the documentation on it. For purposes of example, I want to pick the audio clip, and we provided various audio clips for you. So once again, in the assets under audio, under sound effects, you can see there is a player fire sound effect. And let me go ahead and drag and drop that in the audio clip spot. Now this sound effect we just want to play once, so we do not want to loop. So we won't check that as we've done in the past. Notice there's this play on awake that's currently checked. This lets Unity know that the audio source will play its sound as soon as it's created in the scene. We do want that checked, which is the default. There's also a volume setting, of course, which does what you would expect. It controls how loud the sound is. If you think the fire sound is too loud later, you can go back and adjust this to be quieter. I'm just going to leave it at the default for now. There's also a pitch setting, which controls how high or low pitch the audio is played back at. We're going to leave this at 1, which is the default, but you can try playing with this setting to see if you like the audio pitched up or pitched down, for example. That's one cool thing to control dynamically through code as well, which we will do in a later project. And once again, we have the spatial blend property, which is another important setting. This controls how the audio is handled within the game space or within the scene. Is it a 2D sound effect that doesn't matter how far it is from the audio listener, or is it a 3D sound where the distance actually matters? Now, since this is a 2D game, we typically want to stick with 2D spatial blend in this sort of project, so we'll go with the default there. So now this game object is essentially set up. If you click play, we basically hear the shoot effect, and then it will go away after about 5 seconds. Okay, so of course we don't want this in our scene at the beginning. We want it based on when the player actually fires, clicking the left mouse button. So we want to take this game object that we set up and turn it into a prefab. So once again, I will clean up what I'm looking at over here and go into prefabs and go into effects. And I've got player effects, and let me go ahead and drag and drop this game object out of the hierarchy into that subfolder. And this will make it into a prefab. So we've created a player effect prefab. This is actually a file that's stored, on disk within our assets. And of course, we still have the one out here. So let me go ahead and right click on this and delete, the original one that we created, because we've now got a prefab created out of it. And if I go back to the player and go to the bottom where we have our shooting controller, the last option is the fire effect. And I want to go ahead and drag the player fire effect onto that setting. And let's go ahead and enter play mode. So now when I'm shooting, you can hear the sound effect that plays, and it actually creates all these prefabs as well. And our script doesn't actually put them in the projectile holder. That's something, a modification you could do if you so chose at a later point. Let's go ahead and stop. And I'll go ahead and save the scene. Now, one last thing to do is to change the tag on our player game object. Remember, game object's going to have tags. So if I click on the main camera, the tag is set to main camera. If I click on the player, notice it's untagged. So if I click on the little drop down here, there's various tags that are pre-set up in Unity. And one of those happens to be player, because the player is, of course, an important thing. So we want to choose the player tag for the player. Now, some of our scripts actually depend on this to help identify the player. So we want this, so let's click player in this case. Now our player is basically set up, And whenever we've set up a game object that we think we're going to use over and over again, we want to turn it into a prefab often. So once again, within our prefab folder, we don't have a player folder yet. So let me go ahead and right click on prefabs and choose create and pick folder option. And I'm going to name this player. So we'll hold all of our player prefabs here. And I'm just going to drag my player game object from the hierarchy and drop it right in that folder. And that will create a player prefab that we can use perhaps in future scenes or levels. And let's go ahead and save our scene once again. Now that our player is set up, the next thing that we're going to do is set up our cameras to frame the action. Back in our level 1 scene, you can see that we have already a camera called main camera. We get this by default whenever we create a new scene because there's always a camera in a scene. For this project, we have our own camera with settings already made as a prefab for you to use. So if you go into prefabs and open the camera subfolder, you can see there's a main camera here. And let's go ahead and just drag and drop this out into our scene. Notice we've got 2 main cameras now. It names the second one with a parenthesis 1 to distinguish them automatically. Now let's go ahead and delete the old main camera. So we can right click on that and choose delete. Now we've got our main camera that's based on the prefab with settings already set. And we can go ahead and we can rename this once again back to main camera. And notice one thing it did is it kind of zoomed out the game view to be a little bit smaller. Now without further ado, I'm going to actually separate my player and my enemy a little bit. So let me select on the player and zoom out here in the scene a little bit and then just pull it down using the move tool to separate these a little bit. So, as a player, you have time to avoid that first shot. Okay, let me go back to the main camera. And, you can reorganize like these. I can drag it to the top of the scene if you want to keep it at the top just to organize and always know where the main camera is. Now let's go over some of the settings on the camera. Like any game object, our main camera, of course, has a transform component on it that determines its position, rotation, and scale. For a 2D project, the rotation and scale of our camera are mostly inconsequential. The most important of these properties, of course, is the position. The position is important as the Z-axis is the direction pointing out of the screen. So the camera points from the Z-axis into our 2D area. And you can see my position is at -10 meters off of kind of the flatness of the world. So for example, if I look at my player, notice it's at 0 in the world. And if I change this to something like -11, notice the player disappeared. Okay, we've got a 2D view in our scene, so we don't actually, see the player now. You can actually change this. So if I click the 2D option to go into 3D mode, we can actually see our player here, and we can actually see our camera here, and it's not rendering the player. Let me go back into 2D mode because that's typically what we want when we're editing a 2D game. But just notice you can switch your scene view between 2D and 3D if you chose to. So in this case, our player, we want to go back to 0 in the Z direction. So once again, the camera is positioned so it's actually hitting all these things. And in fact, all of these objects, Z is set at 0. It's a 2D game once again. And the X and Y is what really matters on all the objects. And the Z matters kind of on the camera. Now there are many settings on the actual camera component of the main camera, most of which we won't go into detail on. Once again, if you're curious, you can always look at the Unity documentation by clicking this little icon to bring it up. For our 2D game, we only need to talk about a few of the camera settings. The projection, of course, is the projection on the world. We've got perspective and orthographic. Orthographic, once again, means that the camera will display everything in the scene without a sense of perspective. This works well for most 2D games. And a perspective view means the camera renders objects with their perspective intact. This typically does not make sense for two-dimensional games, but we'll definitely use this in our 3D game projects. Now, if you remember in our solar system project, we had a skybox. In a 2D game, we don't really have a skybox, so the clear flags you could essentially view as set to solid color, and the color is set as the background color. So you can see the blueness in our game view here. That is based on this color. So if you wanted a different color, you can click on this and change the color. So I can change it to black, for example, because I'm in outer space. And that will make the change. Now the size setting controls the size of the viewport. A larger number means the camera is showing more area and objects are therefore smaller, while a smaller number means it will show less area and the objects are bigger. So if I go down to 4, for example, it's going to zoom in quite a bit, and go back to 8, it goes back to the view that we had. Okay, with that change made, let's go ahead and save our scene. Now this camera seems like it has good default settings, so let's keep the change for our future cameras. Since we created the camera from a prefab, we'll be able to apply those changes to all future prefabs of this camera. Once again, you can see that it's based on a prefab up here in the inspector, and then there are overrides on this. Basically I changed the background color, and we could then apply that change. If you actually click on this, it actually shows you the exact change that was made. Mostly the background color here. It says the size changed, but that's because I changed it to 4 and then back to 8. But over here we can click apply all. That will apply all the changes back to the main camera prefab. So future main cameras drug out into a scene will have those same settings. So now if you click on the main camera prefab and look at the inspector settings, of course, the background is set to black. This is exactly what prefabs are for, avoiding having to make the same change multiple times. We can also modify prefabs directly when we have them selected, in the project view. So changes made here will, of course, apply back to game objects built off of those prefabs. So if we select, once again, the main camera here in our project view, and if we go to, once again, the camera component and change the size from 8 to 5, it's going to go ahead and change that. And this change is made across all instances of the prefab. So if we look back at the main camera in the scene, once again, our size is to 5 now because it's based on that prefab. Let's say we like both sizes of the camera and we'd like to be able to easily choose between the two for any level that we create. We could make another prefab. The easiest way to do this in this case is to create a new prefab from the existing one. So let me go ahead and rename my current game object from main camera to large camera as an example. This will only change the name of the object in the scene. It doesn't change the prefab name it uses. Let's go ahead and change this back to 8. So this is kind of the zoomed out or the large camera. Now the game object uses the main camera prefab, but the size property has changed. And you can see it's highlighted there with a little blue indicator. Now to make this its own prefab, once again, we could just drag and drop it. And if I drag large camera over into the camera folder under prefabs, we'll get this little pop-up. It says, would you like to create a new original prefab or a variant from the existing prefab large camera? For purposes of this class, we'll almost always select original prefab. So let's go ahead and do that. This creates a new original prefab that's no longer attached to the main camera prefab in any way. So now we have our large camera with a size of 8, and we have our main camera with a size of 5. I can go ahead and rename this maybe to small camera to signal the difference between the two. Now let's go back to our large camera in the scene to discuss a few other properties on the camera. The next component of our camera is our audio listener, which you can think of as a microphone in the scene that picks up all the audio that happens to be playing within the scene, within the game world. And of course, we talked about this in the previous project. By default, any camera game object you create in Unity will come with an audio listener component attached. If we turn it off and hit play, you'll notice that you don't hear anything because the microphone essentially is turned off. So let me do that and hit play. Notice that Unity tries to warn us, in the console that there are no audio listeners in the scene. Please ensure there's always an audio listener. So let's go ahead and close that and stop, and of course turn the audio listener back on so we can hear audio sources. Lastly, in this custom camera that we made, it's got a camera controller script component. So we didn't get this, in our original main camera, and that's why we brought out the prefab to provide this additional functionality, as well as change some of the settings. So the first main setting here, it says game object references. We can set a target, so this is what the camera should look at. We want it to look at the player, so I can drag and drop the player into the target property here. And there is a camera movement style property. And notice there are 3 options: locked, overhead, and free. I'm going to go ahead and switch this to free. This tells the camera it can move to follow the player around rather than being locked in place. Now, if we go to the look at action down below, this is where we can set a binding for a control that controls the camera. Let's go ahead and click plus here and choose to add a binding. And if I double click on this, it's going to bring up our bindings. And just as we've done before, we can choose the mouse, and we want to pick the mouse position. So mouse position as our binding, and we can see that set here. So this will make the mouse position control how we look around the scene. So let's go ahead and hit play to try this out. So as I move around, notice as the player looks based on mouse position and the camera changes. So I'm actually steering around. I can fly around over the top of this and shoot and destroy it. Okay. So let's go ahead and exit play mode. Now we have everything we need for our camera set up. And let's go ahead and save our scene. In this video, we're going to make our level a little more interesting to move around in. We'll talk about sprites, their settings, and a little bit more about prefabs. Back in our level 1 scene, we have this dark void set up, but we would like our space to be a little more interesting to look at. To do this, we are going to use some sprites to build our environment. Now, if you navigate into Art, Environment, we've got a backgrounds folder, and you can see we've got various backgrounds provided. If you select this, once again, you can preview them over in the inspector and go through the various ones here. You can pick whichever one you want. I guess I'll go with the A option and drag and drop it into our scene. And this, of course, creates a new game object with a sprite renderer component, and the sprite is automatically set to that piece of art that we chose. You might notice that the background has covered up our player, and for you, possibly your enemy, or maybe neither. This is because all of our sprites so far have been on the same, what's called a sorting layer, and have the same order in the layer. We can see these settings if we look at the sprite renderer's additional settings here. Notice there's a sorting layer option that's set to default, and there's an order, which is set to 0. And if I look at the player, it's got the same settings. Now, if we want to make sure that our background is in the background, we need to set up our own sorting layer. So let's go back to the background object. And if you click on sorting layer, notice that it's set to the default. I'm going to click add sorting layer. This will bring up interface in the inspector, and you can see there's different types of things. There's tags, which we talked about before. We can create our own tags, and there's layers. But we want, for 2D games, we want to use the sorting layer. So right now we've got the default. I'm going to click the plus, and I'm going to make a background layer. So I'll type background here, hit return. Now we want the background to render behind the default layer. So reorder the layers by clicking and dragging them from the left side of the list using the double bars. So I'm going to drag the background to be above default because kind of view it as you're looking from the bottom of the screen up. So default in this case would show first and then the background behind it. Or if you view it the other way, it's going to render the background, then it's going to render default on top of it. So let's go back to our background game object now. And for sorting layer, let's go ahead and pick background. And notice that immediately I can see both my enemy and my player with the background behind it. Now the background doesn't completely cover everything our camera renders, as we can see in both the game view and the scene view. One solution to this might be to scale up the background game object. If we click, of course, our scale option here, our rect option or the scale option, we can scale up that game object. But notice if you do that, it might make that very pixelated looking. Okay, let me go ahead and undo that using Control Z on Windows or Command Z on the Mac. And you can also just go back to 111 in the scale setting. So the better solution for this case is to create actually more backgrounds. Our background art assets were created to fit together with themselves seamlessly, as you can see if we create another one of them. So let's go ahead and do that. So with this option selected, let me duplicate this. So on Windows, with a game object selected, you can choose Control D for duplicate. On the Mac, it would be Command D, and it creates a new game object. So now I've got two of them stacked on top of each other. And I'm going to switch back to my Move tool. And if I drag this, notice there's two of them. But I actually want to kind of snap them together. And Unity actually provides a snapping feature. Now, if I roll the mouse to the edge of this game object, let me zoom out a little bit more and hold down the V key. Notice that my gizmo went from the center out to the outer corner. Now, with the V key held, I can move this and get it close, and it will actually snap right to the other sprite. So let me actually do that again. I'll go ahead and select this one and do Control D on Windows or Command D on the Mac. Of course, you can also right click and choose duplicate as well. And with my move, of course, I could freeform move it, but it's really hard to line that exactly. So with the mouse in the scene view, I can move over to the edge, hold the V key down, and I get, once again, my gizmo snaps to the edge. And then if I drag this, it will snap to the edge of the other sprite. So I've got three of these kind of set up, and let me actually select all three and duplicate all three. So I've got three more, and with those selected, once again, I'll hold down the V key and, I'll move them, I guess, first, and then I'll hold down the V key to get my little snap. And now I've got basically 6 of these all set there. So I've got quite a bit of space that I can fly around. So if I go ahead and hit play, we can demo this, and you can see I've got the space around me, but of course, you can fly outside of that background. So we want to keep the player kind of constrained, within that space. So let me go ahead and hit stop. Of course, there's multiple ways of handling this in the game. What I'm going to actually do in this project is basically create a collider that stops the player from going out of the background area. And I'm going to visually represent that collider with an asteroid belt. So within the prefabs, I'll go ahead and close the art now and open prefabs and go to environment and hazards and open that. And we've got a stationary subfolder, and we have an asteroid border subfolder. Let me open that. And here are some folders containing prefabs made to use as a barrier to stop the player from moving beyond the space that we want them to play in. So for example, I've got corner pieces here, and they're named fairly logically. So we've got a lower left corner, and I'm just going to drag this out into the world and drop it. And once again, let me kind of zoom in on it. If I tap the F key, it zooms right to it. And if I hold down, once again, the V key, I could then snap it right to the corner of the background. And let's drag out the lower right and do the same sort of thing. Once again, tap F to zoom in, hold down the V key, and then as I drag, it'll snap right to it. Let's bring out the upper left. Zoom in with the F key, and then snap it with the V key. And then, once again, I can zoom out a little bit, move over to prepare it, and then the upper right. We'll zoom in with the F key, hold the V key down, and then snap it. Okay, so those are our corners defined. And notice we also have a walls subfolder. So let me go ahead and grab a wall. So I've got a top wall. You can do this in any order, but let me bring out a top wall here. And once again, holding the V key down, I could snap that into place to connect to the corner. And now with this here, I just need to make multiple of these so I can once again duplicate, Command Control D on Windows or Command D on the Mac, and you can move it over, and then holding that V key down, I could then snap it to the other one. And you can kind of make your life a little more efficient by selecting two at the same time and duplicating both of them, moving them, and then using the V key to snap them. Looks like I need about one more, so let me duplicate the last one. Move it over, use the V key, and snap it. Okay, so I've got my whole top built, and now I'm going to go through and do rest of it. I'll fast forward. You can watch it if you want, but you can do whatever something very similar to what I'm going to do. Okay, I've got my whole border created now, and you can see it there in the scene view. We can see our hierarchy has gotten very cluttered with lots of game objects. So let's go ahead and create a new empty game object to hold all of these sub objects. So let me go ahead and create an empty object, and I'll go ahead and call this my border. And I'm going to select all of my border objects and drag and drop them within the border parent object. So those are all my border pieces. And, to further clean this up, I'm going to go ahead and create another one. And I'm going to call this my background. And I'll go ahead and drag all of the background objects and put them into the background. And of course, we can collapse, both the background and border to clean up our top level of our hierarchy. Now let's go ahead and enter play mode. So we can see we have our entire environment. We've got our borders around the outside, which we could, run into and not go through. So we've got a fully defined play area for this level now, this scene, with a player and an enemy. And of course, we can destroy the enemy. Okay, let's go ahead and exit play mode and save our scene. In this video, we'll begin setting up the game loop and user interface through the use of two manager scripts, the Game Manager and the UI Manager. Back in our level 1 scene, we still don't have that much for our player to do. We've defined play space for the player to move around in, and we've created one enemy for the player to interact with. But there still are a lot of typical elements you'd see in a game missing from our game. These elements include an actual gameplay loop that distinguishes a start and end of gameplay, as well as user interface to report performance back to the player and give them additional controls over their gameplay experience. To manage the gameplay loop, we have provided a Game Manager prefab. So once again, let's clean up a little bit and look for the management folder within our prefabs. And you can see the Game Manager here. Let's go ahead and drag and drop it in the scene. Its position in space doesn't matter because it's purely for management, not for rendering. So you could even take it and move it, outside of the play space just so it's not confused. The Game Manager prefab only has one important component. Once again, the transform doesn't matter for this. And that component is the Game Manager script component. This script keeps track of the game state information, such as whether the player has won or lost. The Game Manager also handles responding to the player losing or winning the game. Now, creating a Game Manager script is a common thing you should do in most Unity games, as we've done here. Notice that Unity even recognizes the importance of this script by putting a little gear icon here, versus if we go back to the player and look at a typical script icon, it looks like a little, page with a sharp symbol on it for a C# script. Now, this Game Manager is also a C# script, but since it's a Game Manager, it uses the little gear icon just to signify its importance. Now, the Game Manager script that we provided has several settings. The Game Manager wants a reference to the player to start with, so we could go ahead and drag and drop the player into this spot so it knows where the player is. There's also settings for the game score and high score. And notice there's also game progress and victory settings, and game over settings. We'll look at these more later and get them all set up. Now, one of the things I want to point out about the game manager that we provided in this project is that it's made specifically for this game. That means if you want to use this game manager for another project, you really couldn't. Whereas many of the other scripts we provided can easily be reused with little or no modification, such as the health and damage script. At some point, we'll discuss ad hoc code as well as generalization in code. But I wanted to point out with these more managerial scripts we provide cannot be reused without modification in other projects. With that said, you can use them as a reference for your own game manager scripts. Now, while the game manager manages the gameplay loop, we have another manager, the UI manager, that manages our user interface in the game. Let's add the UI manager now. So once again, drag and drop it in the scene, and we can move it out of the kind of visible area of the camera. Now, the UI Manager prefab has a script on it called the UI Manager, which controls the user interface that's displayed in the game. Let's go ahead and enter play mode. Now you'll see that we don't have any UI set up, and we get a set of warnings in the console window. If we click on this, we can see those. Both messages are generated by the scripts that we provided and are meant to help us figure out how things should be set up. Let me go ahead and stop for now, and we can look at these a little bit in the console window. The first warning says there is no event system in the scene, and the UI in Unity requires an event system to run. Now, Unity UI needs two things to operate: an event system and a canvas. If you create a canvas, Unity will add an event system game object for you automatically. So this is typically how you get your event system. So let's go ahead and close the console window. And if we right-click in the hierarchy and choose UI and pick canvas, this will create a canvas game object and an event system game object. Now, Unity's UI navigation uses the event system, so whenever a canvas is created and no event system exists, Unity creates one for us, which is a nice thing. Now, before we start fiddling with the canvas to get our UI set up, we need to edit the event system game object. So go ahead and click on the event system game object and look at the inspector. Notice one of the components is called standalone input module, and there's a big warning at the top here. It's alerting us that we need to replace it with an input system UI input module, which we need to do for the event system to work with the new Unity input system that we're using and set up earlier in the project. And we can just simply click this replace button at the bottom, which will take care of that for us. Now our event system should be set up correctly, and we've got a canvas game object that we'll use to create user interface within. And that is the topic of our next video. Let's go ahead and save our scene. In this video, we'll start to set up our user interface, starting with the score. Unity actually supports multiple methods for creating user interface. IMGUI, or Intermediate Mode Graphical User Interface, is the original code-based UI system in Unity. The original Unity editor was actually written using IMGUI. Most people do not use this system anymore unless they're building extensions to the Unity editor. UI Toolkit is the newest UI system in Unity. It is inspired by standard web formats, such as HTML and CSS, to create UI elements. It may become the recommended way to create UI in Unity in the future, but it's still missing some key features. The third method is the Unity UI package, or UGUI. This is a game object-based UI system that uses the canvas as its organizing element. By default, a canvas is basically a 2D overlay to put user interface elements within. It can hold objects such as text, images, and buttons. We'll be using UGUI in this project. Go ahead and click on the canvas game object. Notice that it has a canvas component on it, a canvas scalar component, and a graphic raycaster component. These are the default components that will be on most canvas game objects. We'll leave the settings alone for now and start adding the UI we want to the canvas. Then we'll come back and look at some of the components on the canvas. Okay, if you right-click on the canvas, of course it brings up the add option, and we want to create new UI. And let's go ahead and pick Text Mesh Pro and select that. You're going to get a little warning here that says that we need to import the Text Mesh Pro essentials. And Text Mesh Pro is sort of like a package that is provided by Unity. It's a third-party package that they acquired, they bought, and now it ships with Unity. But we need to bring that into our project the first time that we use this. So I'm going to go ahead and click this Import Essentials button. And this will go through the process of importing that into our project. And we don't need the examples and extras, so let's go ahead and just close this. Notice we have a new Text Mesh Pro folder in our assets. And there should now be a text, TMP object as a child of our canvas. Now within the scene view, you probably can't see that game object, but you can see it in the game view. And the reason you can't see it in the scene is your canvas is actually a very large thing. So if I actually, go ahead and click F, or if I tap F on the keyboard, it's going to zoom to this object in the scene. And if you, use your mouse wheel to scroll out, you can see that the actual game is this little small area here, and this big box is our canvas that represents kind of the 2D overlay screen, and right here is our text object. Now this text game object we're going to use to hold our score. So let's go ahead and rename this from text to score text to make this a little more descriptive. And then let's look at the components. And one of the primary components is the Text Mesh Pro text component. And I'm going to make the preview area a little smaller here, so I got more visibility here. And the first option I'm going to do is actually set the text of this component. And I'll change it from new text to say score: 0, because this is going to be, of course, our score indicator. Now, one of the things that we can set is a font asset, and Text Mesh Pro comes, with a couple fonts to choose from. But one of the things that you can do to provide a visual style in your game is, of course, use your own fonts or use, third-party fonts. Since we are making a retro sort of 2D shooter game, we've included a font for you to use within our assets. So within Art, if you open that and find UI elements, there is a fonts subfolder. And there's a font called Mana Space. Now this font is actually a true type font, which is a common font format that you can find out there on the internet. And we actually acquired this, and there's a license file here that you can see that we have the rights to use this in the project. Unfortunately, Text Mesh Pro does not support true type fonts directly, so we need to convert the true type font into a Text Mesh Pro friendly font. And we can do this by simply right-clicking on this and going to Create, and go to Text Mesh Pro, and then we can choose Font Asset. So based on the font being selected, it allows us to create a new font asset, and it does it right here. So it created a new asset called, Mana Space SDF. So as you find true type or open type fonts on the internet and want to use them within Unity with Text Mesh Pro, this is a common thing that you'll need to do, is convert it into a Text Mesh Pro font asset. Okay, now that we have our Text Mesh Pro compatible font asset, this font is ready to use, but we can customize a few settings to make it look a little bit better. Since this is a retro, sort of pixel aesthetic, we don't want it to be like smooth edges. We want it to be more pixelated. So with that font selected, one of the things that we can look at is the Atlas render mode. And, you'd really need to read the documentation to understand all these things, but just follow along here. I'm going to switch this to SDF as the mode of rendering. So I'll change that to SDF. And down below, you need to click Apply to make that change take effect. This will remove some of the blurriness in the font. Now, one other thing that we can do to remove the blurriness and make this more pixelated is if you drop the little cascade down here and go to the mana space atlas. I know it's a little hard to see that here, but it's this one, the mana space atlas, so the one with the brick icon. So select that, and in the inspector, we can see there is a filter mode setting, and it's set to bilinear. If you select that and switch this to point, that'll make it more of like a pixelated sort of rendering. Whenever you want to be exact pixels for filter mode, switch it to point. If you want more like anti-aliasing, one of the other options is typically okay. So I'll switch this to point, and this will further reduce the blurriness of the font, making it pixel perfect. Now, depending on your font, of course, you may not need to do these last few steps, but I just wanted to make this look the way we want it to look. Okay, so let's go back to our score text object, and I'm going to reset my layout back to favorite since I moved the panes around a little bit. So going back to my score text game object under the canvas, we can go ahead and select our font asset now. So let me hit the little target symbol, and I'll pick the mana space font, and you can see it changed there in our game view, and it's that sort of pixelated looking font. Now, if your text isn't white already, you can change the color under vertex color, and you can pick whatever color you want, but I actually want white since it's going to be over kind of a dark space background. So I've got that set there. And I want this in the upper corner of my game view. So once again, when the game object is selected, you can see the outline of the overall canvas. And I want to just kind of move it up in the corner. So I'm going to change to the move tool, and I can drag it sort of up here in the corner. Okay, and we'll make some changes later, but for now, let's just put it kind of up there in the corner. Now that we have our score text created, let's add a text object for our high score. So a sort of shortcut is we want to use essentially the same settings here with the font asset and the color. So let me go ahead and just duplicate this. So I'll right-click the score text and duplicate, and rename this to high score. And of course, it's overlapping the other one. So let me just move it down a little bit. And then I'm going to change, the actual text that's displayed to high score, :0. And notice that it actually wraps here. And that's defined by this yellow box that defines basically the size of this, the width and height that you can see in the rect transform component at the top of this UI asset. And I can just, grab the little anchor point here and drag this out a bit until it doesn't wrap anymore. Okay. And let's go ahead and save our scene. And the last thing that we want to do is get our score and high score to update correctly. Fortunately, we have some scripts to do this for us. So if we click on the score text game object once again, let's go down to the bottom of the inspector and choose Add Component. And we provided a score display script. So if I just start typing score, you can see we've got our score display script here. And I'll go ahead and select that. And one of the settings is the actual display text, which is essentially itself, so we want to drag itself onto this spot. So that's the score display script will target that when it's updating the score. And basically what this script does is it updates the score display when the game manager tells it to do so. So for example, when the player, shoots an enemy, they get points for that. So the score is updated, and this will then update what's shown in the score text property. So let's go ahead and hit the play mode to see how this works. Okay, I killed the enemy. You can see I went from 0 to 5. So everything is working there. The game manager, recognized that, updated the score, and then that score display script actually updated the actual property here. So you can see here in the inspector under the Text Mesh Pro component, the actual text now says score 5. And of course, I'm in play mode. As soon as I hit stop, this will reset back to score 0. Okay, the high score is set up in a similar manner. So if I select the high score text game object, I can click on Add Component, and I want to add the high score display script. Since I was already searching for score, it shows up here, and I'll go ahead and select that. And once again, its one property is the display text, and we want to set the target to be the Text Mesh Pro object that we want to update. In this case, it's itself, so I can drag the high score text onto that, and it will target that Text Mesh Pro component on this game object. And let's go ahead and enter play mode again to test this. And you can see as soon as the game starts, it actually updated it, and it just says hi:5. So my mistake earlier for adding score. But you can see it pulls this because it remembers from the previous game, it saved that as sort of a preference that we had acquired 5 points previously. So it immediately updates that. And of course, the score is back to 0. If I kill this enemy, I get 5 there. And there's only one enemy, so we can't go above 5 at this point. Let me go ahead and stop that. And I'll go ahead and update the default from high score to just hi:0, so it looks similar to the way the script is set up in terms of what it replaces when it actually gets a high score. Okay, let's go ahead and save our scene. In this video, we're going to add a pause screen to our game. You might have already noticed that the UI Manager's UI Manager script, if I select that, has an input action called pause action. We're going to set up a binding to allow the player to pause the game the same way we have been setting up bindings for our other inputs. So once again, if you go ahead and select the UI Manager and scroll down in the inspector so you see the pause action, go ahead and click the little plus and choose Add Binding. We have our binding here, but it's not set. If you double click this, it'll bring up the interface where we can set the binding path. And if you click the drop down, we can set it in a number of ways. I'm going to start typing escape in my search because I want to use the escape key to pause the game. And you can see there in the search, it comes up with escape on the keyboard. And I'll go ahead and select that. And you can see that binding is now set. So this ultimately will allow the player to tap the escape key to pause the game. So let's go ahead and save our scene. Now we have the binding for pausing the game, but we still need user interface or UI set up to display when the game has been paused. So let's start by creating new UI. So all of our UI once again goes on our canvas. So let me right click on the canvas and choose UI. And I'm going to pick image in this case. Okay, and this is going to make a white box here. And I'm going to rename this as pause screen. And of course, we want to make this look better. So with an image UI element, it has an image component. And one of the properties that we can set is the color, and that's why it's white. But we can also set a source image, which is what we want to do here. Now within our art folder, under UI, we've got a backdrops folder. And one of those items is the UI backdrop. And let me actually just drag and drop that as the source image. And you can see the white box was replaced with a sprite. And this will serve as sort of a dialog box for the pause screen pop-up. And this is a little small now, so we can scale it up. So one of the things we can do here in the scene view is we can switch to the rect tool. This will show the little anchor points on the pause screen game object. Now, if I just start dragging these, notice I can drag it to any sort of size I want and not maintain the aspect ratio. So let me stop that and undo to go back to the way it was. But if you hold the shift key down while dragging, notice that I can't actually change the aspect ratio. Now I want to drag this up to be a little bit bigger. You can actually look in the inspector and actually see a size, a width, and a height. And maybe I'll go to something around, 210. As close as you want to get. I can also go in to the width and just set this manually to 210 and the height to 210, so it's a square. And the position, I can set this back to 0, 0 to center it up, so it's right in the middle of my canvas. Okay, we have the background of our pause screen set. Let's add a text title to let the player know that the game is paused. If we go ahead and right-click on the pause screen game object and go down to UI, we can choose, once again, our text Mesh Pro option. And this will create a child object of the pause screen. And you can see it out there in our game view. Let's go ahead and rename this as title. And once again, we have this sort of parent-child relationship here, and it's important that the title is a child of the pause screen. Notice if I actually drag and drop this out of the hierarchy and have the title above the pause screen, we can't see it because the pause screen is actually above it. If I drag it below it, but not as a child, it's overlapped, but it's not a child. So if later I actually moved the pause screen, notice that it is actually a separate thing. Let me undo that. Control Z on Windows or Command Z on the Mac. And once again, we want to make the title a child of the pause screen. So I'm going to drag and drop the game object onto the pause screen, and it's now a child, which of course you can open and close the cascade to really realize that. So now, once again, if we go to the pause screen and, if we move the pause screen or relocate it, the title goes along with it. Let me undo back so it's centered. Now let's set up the title a bit. We just want it to say paused. And we want to target the right font asset. Once again, we'll use the Mana space font to get that sort of style that we were looking for. And of course, you can also change the size if you want to be a different size. I'll just go with the default here. And then we could actually position this. So using the move tool, maybe I'll move it to the top because eventually we're going to have some buttons and kind of centered. And one other property that we can change on the text mesh properties, if we scroll down, is we can set the alignment to centered. And that's the horizontal alignment. And there's also a vertical alignment. We could set that to middle as well. And once we do that, notice that we are centered within that yellow box here. And once again, we'll go ahead and reposition to be kind of in the center of our background object. And, we'll come back to this and tweak some of these options later. But for now, let's go ahead and save the scene. And the next thing that we want to do is we want to add a button to unpause our pause screen. So the way we add a button is very similar to what we did before. By adding text, we can just right-click on the pause screen and go down to UI and choose the button option. And when I do that, it creates a new game object. Rename this as my unpause button. And you can see it already has some child objects. So if I actually open the cascade here, one of those child objects is the actual text that says button. And I want to change this from button, of course, to say something like unpause. And we can go ahead and change the font as well and change it to maybe that Mana font. And of course, you could change things like the font size and the color and that sort of thing if you wanted to. Now, if I go back to the unpause button, notice it's got various components on it. One of them is the image, and that's sort of defining this sort of rounded rectangle that we see here. And this is an actual built-in UI sprite. If you wanted to change this and make it your own style, you could, of course, do that. So let's go ahead and do that. We can look in our project under Art. We've got, under Art, UI Elements, Buttons. We've got a UI button sprite sheet. And if you open that up, it's got, various sub-elements for UI button 0 and UI button 1. Let me go ahead and drag UI button _0 onto this. And you can see that it immediately updated and looks nicer and maybe more styled for this game. Okay, let's go ahead and play and see what it looks like in game. Okay, if I roll over it, notice it slightly changes color. And if I press it, it slightly changes color as well. Okay, let's go ahead and stop that. These are all the default behavior on a button. And these are all, of course, properties that we can adjust in the editor. So if we select the unpause button again, let's go down and look at the button component. And notice it's got different colors that we can set for the normal state, the highlight state when you roll over the button, a press state, a selected and disabled. And the transition setting is set to color tint. So, it's basically changing the tint on the sprite based on these different actions. And if I click this little drop down, rather than color tint, I can choose sprite swap. So let me go ahead and do that. And now, rather than colors, I can set different sprites for the different actions. So if you remember, we had two different sprites, the 0 and the 1, and I'm going to actually change the highlight to the 1, and the press to the 1, and the selected to the 1, and I'll just skip the disabled. It doesn't actually ever get disabled. So now if I enter play mode again, you'll see that the button now kind of has this effect on it. And, we don't have different states of the button. If you could actually create different sprites for the different states, but, we've got at least a customized state for highlighting, pressed, and selected. Let me go ahead and exit play mode, and we'll save our changes before we continue here in the scene. Now, Unity has a weird selection bug with its UI when you have both a mouse and another device, such as a controller, to navigate UI. In the right circumstances, it highlights both an option your mouse is hovering over as well as the option that you've selected with your other device. And that's kind of what we saw there. We've provided a script to fix this bug. So with the Unity pause button selected, if you scroll down and add component, we provided a script called highlight fix right there. So I started to search for hi and found highlight fix. And let me just add that script component here, and it doesn't actually have any properties. It just fixes it. Now we've got our button looking nice, but it doesn't actually do anything yet. So that's our next step, is we want to make the button functional. Now, if you look at the button component, there is an on-click option here. And this basically means when you click the button, what do you want it to do? So let me click the little plus here. And this adds some user interface that we can use to set what we want to have happen on click. And you can actually add multiple of these if you want. I'm just going to have one. So each of these we want to set a target. So this is the game object that controls kind of the code that's going to run when we click. So our UI manager actually has this functionality. So we want to drag our UI manager right here. And by doing that, it populates this dropdown, which are a set of functions that we could actually run. So if I click on this, notice that we can pick the UI manager, and this shows all of the public functions that the UI manager has and some additional things. And one of those functions is called toggle pause. And that's exactly what we want. If you actually looked at this script, toggle pause is going to toggle the pause state of the game. So let me go ahead and select toggle pause. And now we have the button functionality set up there. So let's go ahead and enter play mode and test this out. Okay, now when I click the pause button, notice that the game is paused. If I kind of move around, you can see that everything is paused. And if I click it again, it unpauses. Okay, so we're every time we click it, it toggles the state of being paused or unpaused. Okay, let's go ahead and exit play mode. And let's go ahead and save our scene. Now, of course, our pause screen is up all the time. We don't want that. And that's one of the things the UI manager manages. So if we select on the UI manager and look down here at page management, it has a list of pages. If I open this, and right now it just has one element and nothing there because we haven't set those up yet. So let's do that with our pause screen. So let's go back to the pause screen. And in order to make it a page that we can put here, it has to have a UI page component. So if I go back to the pause screen and go to the bottom and click add component, I can choose UI page and select that. And now it has a UI page component on it. And one of the options is what is the default selected button. And the default selected button we want to be the unpause button. So let me drag and drop that here. So the UI page is set up. Now if we go back to the UI manager with our pages here, once again this is looking for a UI page, which we just set up on the pause screen. And I could just drag and drop pause screen on this spot. And this is effectively the first page or the 0 element of our pages. And down below here where it says pause settings, we can pick the pause page index. And right now it's actually set to 1, but above we set it to 0. So we need to make sure that this number and this number are the same. So in this case, I would change the 1 to a 0 to say that the pause page index is the 0 element of my pages above. And let's go ahead and test this. So let me hit play. And sometimes when you're testing things in the editor, you have to kind of click on the game view so keyboard input goes into that and not on the rest of the editor. But if I hit escape now, notice that the pause screen goes away. I just died, so the default behavior is it's going to bring up that UI. So let me stop and press play again. And this is kind of where the play maximized might be nice. So let me switch this to play maximized and hit play. Okay, and let me move over so I'm out of the way. And if I hit escape a couple times, it goes away. Hit it again, it comes back. And I'm toggling between paused and unpaused. And when it's up, I can also hit unpause here, and it also unpauses and gets rid of the UI. Okay, let me go ahead and stop. Now, obviously, we don't want to start with the pause screen up. So let's click on the pause screen game object. And at the very top of the game object, there's a checkbox right next to the name. And this basically means the game object is enabled or active in the scene. So let me make it unactive or disabled so we don't actually see it. And it grays it out here in the hierarchy. And it grays out the parent and all of the children, which is what we want. Now, if we enter play mode once again, let me hit play. And let me fly my ship over out of fire. And now if I hit escape, it should bring up pause and pause the game. And if I hit it again, it should take it away. Okay, so we have that toggle. And of course, when it's up, I can also click on the button and that also unpauses it. Okay, let me exit play mode and I'll switch this back to play focused so it doesn't maximize and go ahead and save my scene. If you noticed in the last video, when I maximized the game view on play, my score indicators were no longer in the top left of the screen. That is because I set their position based on the size of the game view. When I maximized the game view, it became much larger. Effectively, I went from a small game screen to a large game screen. The games we make often need to play back on different size screens with different resolutions set. We need our user interface to be designed in a way to be responsive and scale to the size of the screen the game is playing upon. That is the topic of this video. So let me start by turning the pause screen back on just so we have some additional UI on the screen. So let me select the pause screen game object and make it active once again so we can see it there in the game view. Now in the game view, notice right here it says free aspect ratio. If you scroll down, notice there is a 16:9 aspect ratio. Let me select that and notice it actually clips off a big part of my scoreboard because I lost effectively these edges of the screen. And let me make one additional aspect ratio. So I'm going to make a 4:3 aspect ratio. And right now it doesn't exist. So I'm going to click the little plus here. And I'm going to name this 4:3 aspect. And the type here, rather than fixed resolution, which would be if you want to set an exact width and height resolution, I'm going to change this to aspect ratio. And I'm going to set this to 4:3 and say OK. And that's going to make a new custom setting here. So if I select 4:3, notice that I can't see my score at all. Okay, so let me go back to free aspect so we can see it again. So overall, you can see that our user interface doesn't uniformly adjust when we change between aspect ratios. And this is certainly problematic when we go from one screen to another. So both, the size of the screen matters and the position of the UI elements on the screen. So let's click on our canvas game object. One of the most important things about a canvas is the canvas scaler. So if you scroll down, here is the canvas scaler component. This controls how the canvas scales across different screen sizes and displays. Its default setting is constant pixel, which means the UI in the canvas will always take up the same pixel size. This can be problematic when we're playing back on different screen resolutions. let's go ahead and change the UI scale mode from constant pixel and switch it to scale with screen size. Now the reference resolution is the screen resolution that the UI layout is designed for. If your game was designed for a specific resolution initially, you could set that here. So for example, maybe 1920 by 1080 if it was a high definition display. For now, we'll just leave the reference resolution with the default 800 by 600, but you can play with that later if you so chose. And the next thing is when we scale, what do we want our screen match mode to be? So we can choose match width or height, expand or shrink. I'm just going to leave it at the default for now, but then we could decide, do we match the width? Do we match the height? Or do we match somewhere in between? And I'm going to set this to 0.5 to be kind of right in the middle between width and height. So now if we come back here and go from free aspect to 16 by 9 to 4 by 3, you can see it's somewhat helped with our problem. And notice the size of our pause screen, is effectively scaling as we go to different sizes based on that reference resolution. But we still have an issue with our score indicator in the upper left of our screen. So let's go ahead and click on our score text object. And one thing you'll see in the scene view is you see these little triangle points. And these are your anchor for your UI object. And typically the anchors are set at the middle of the parent's game object, or the middle of the canvas in this case. So the position of this object, if I look at the top where you can see the position X and the position Y, is based on that anchor position. So it's 343 pixels negative in the X direction, and it's 140 pixels up from that anchor point. So one thing that we can do is we can change where our anchor exists within the canvas. So if I click on this little gizmo here where it says middle center, we can then get this anchor presets. And for the case of a game object that we wanted to be based on the corner of the screen, we can actually pick one of these presets. And let me go ahead and notice it says shift to also set the pivot and alt to set the position. If I hold shift and alt on my keyboard and then click this, it's going to move this game object to be in the top left corner of the canvas or the parent game object. And you can see it actually moved the anchor points from the center where it was before up into this top left corner. Okay. And now that I've done that, it actually, because I held the alt key, it actually repositioned this game object. So right now it's at 0, 0 from the anchor. So if I go back to my move tool, notice when I move it off the edge a little bit, the X is going up. And if I move it down a little bit, it's going below the anchor. So it's going negative. Okay. So now this is based on that anchor position. And if I change my effectively my screen size by using this drop down here, so let me go to free aspect to 16 by 9, you can see that it stays at the same relative position to the top left corner, or 4 by 3. Once again, it stays the same relative position off of the anchor point, which changes, as we change the size of the display, and you can see it up in the scene view. Okay, so we've made our score display responsive. So let's do the same thing for our high score. If you click on your high score game object, let's click on the little gizmo again. And we want this to be based on, once again, the top left of the screen. And if you, once again, hold down Shift and Alt on your keyboard, it's going to, set the pivot points and also set the position of the game object. Okay, so our high score now is off the edge. Of course, we don't want them to overlap. So if I look at my score text, it was 18 in the X. So let's set the high score text to be the same thing, 18. So they're effectively aligned. And then let me just drag it down to be below the score, wherever you want it. Okay, So once again, if I go through different aspect ratios, it's always going to adjust properly so we can always see the score and the high score. Now let's look at our actual pause screen. Now the pause screen, once again, its anchors are in the middle, which is actually probably what we want because we always want the pause screen centered. So once again, if we click on this, you can see that it's aligned with the middle center. Okay, and that's our little pivot points are shown right there. And once again, our position here is 0, 0 from those pivot points. So our pause screen is effectively in the center of the screen. Now, these pivot points are based on the parent game object. So the parent of the pause screen is the canvas. But if I go to the title, the parent of this is the pause screen. And its anchor points or its pivot points are the center of the pause screen. But if I always want the pause title to be toward the top center of this screen, I can do the same thing using this little tool here. I could go to the top center. Once again, maybe hold down the shift and the alt. And now that moved this to the top center. Once again, maybe it's kind of too top. It's at position 0. So let me pull it down a little bit. Now, if this parent object, the pause screen, ever gets bigger or smaller, this is always going to be, the same amount down from the top of the display. Now, once again, if we click on the unpause button, it once again has its pivot points right there in the middle. It's at position 0, 0, which is probably okay for purposes of this UI element. Okay, now our user interface is fairly responsive to different aspect ratios and screen resolutions. If I go back and choose play maximized, let's go ahead and turn the pause screen back off as we had before, so it's not on initially, and then play. Our game view will get very large, and once again, our scores will anchor accordingly. If I hit the escape key, once again, this will be centered. The pause will be the top center of that area, and the pause button will be right in the center of the pause screen. So now our UI, once again, is very responsive to a larger display, virtually in this case when we maximized. And as we change different aspect ratios, we also get the appropriate anchoring or pivot points for these UI elements. Let me go ahead and stop playing. And let's save our scene. Okay, we have the pause screen mostly set up now. In this video, we want to add 2 additional screens, one for when the player loses and one for when the player beats the level. Okay, we have the pause screen mostly set up. We want to add 2 additional screens, one for when the player loses and one for when the player beats the level. To save us some time doing more of what we've already shown you, we've provided a few prefabs to flesh out the victory screen and lose screen. So let me go ahead and clean up my project view here a little bit, collapsing some folders. And within prefabs UI, we've got 2 screens here within UI pages. We've got a game over screen and a level victory screen. So we're going to go ahead and drag the game over screen first and drop it in our canvas. And you can see it here in our game view. It looks much like the pause screen, except it says game over and it has a main menu button. Let's go ahead and change the font on these things. So just like our pause screen, we've got a top level game object here, which we can open up. And within that, we've got the UI backdrop, which is the image that defines that backdrop. And within that, we've got the title, which is game over. And within our Text Mesh Pro component, we could go ahead and change the font asset. So I'm going to go ahead and do that and change this to the Mana Space font. And it makes the change there. And I can also look at the main menu button. And once again, within that, it has a piece of text. And I'll go ahead and target the font asset there as well and change that to Mana Space, just so we get the same font everywhere. Okay, so we've done some overrides now to this prefab. So you can see that here in the hierarchy. We've got this blue line here showing that there are overrides to the prefab. And once again, if we click on that at the top of the inspector, you can see it's based on the game over prefab. And if I clicked overrides, we can see what those are down here. And once again, if you tap on them, you can see the sort of before and after of those things. And you can individually apply these, one at a time, or you can just click apply all, and those will apply back to the prefab asset. Okay, we've got our game over now. Let's go ahead and drag the level victory screen prefab over, and once again, drop it on the canvas. And when you drop it on a parent, it usually becomes the bottom child. And once again, these render kind of from the bottom up. So just like before, we can open this up and find the title. And here we go. Let's go ahead and change the font asset on that. Once again, to the same title asset that we've been using. And, of course, you could change the color if you wanted to, or any other properties. And let's go into the next level button and select the text element on that and go ahead and change the font asset there as well. And notice the level complete screen is actually off of center a little bit. So let's look at that quickly. Let me click on the parent game object and click on our little gizmo here. And once again, I want to center this. So let me hold down our Shift and Alt again. And let's say center that. And that will snap it back to the center there. Okay, we have both of these screens now in our scene, but they're not yet set up in the UI Manager or the Game Manager. So let's go ahead and click on the UI Manager. Remember, we've got these pages set up, and right now we currently just have the pause screen. So we need to add an additional element for the game over screen. And there's sort of two ways of doing this. Kind of a simple way is you can actually drag one of these over the game over screen and actually drop it right on the pages where it says pages. And if I drop this, it actually makes a new element and adds the game over screen. Another way to do this, of course, is to click the plus. That's going to add a new element, and it kind of duplicates the previous element, so it's got the same target. But we don't want that, of course, so let me drag the level victory screen over and drop it on that spot. So overall, we want to have 3 pages defined in our UI Manager, one for the pause screen, one for the game over screen, and one for the level victory screen. And notice the element numbers on these, once again, 0, 1, and 2. So if I go over to the Game Manager and look at some of the properties of the Game Manager script, we can actually set the index number of the appropriate screen. So here's the game victory page. Once again, if I look back here, the victory is element 2. So let me go ahead and set this from 0 to 2. And the game over index is element 1, or index 1. Okay, so we'll set those so the Game Manager knows those, and when a level victory happens, the Game Manager tells the UI Manager to bring up, the second element here, and when you lose the Game Manager tells the UI Manager to bring up the first index page. Okay, these screens are ready to go. Before we continue, let's make one modification to the pause screen. When we pause, it would be nice to allow the player to not only unpause, but also go back to the main menu, like we have in the game over page. To get this functionality, we can actually duplicate the main menu button from the game over page. So once again, under game over, we've got the main menu button here. I'll just uncascade that, and I'm going to duplicate this. So let me right click and choose duplicate. This made a new main menu button, and I want to drag and drop this into the pause screen. Okay, now, once again, we need to kind of see this to place it. So let me close these guys up, and I'm going to disable them in the inspector so we don't see, I guess we'll do them from top down. The level victory screen will disable, and then we see the game over. If I go to game over and disable that, now we don't see anything, and I want to re-enable the pause screen. So we see that, and we have 2 buttons here now. And once again, if I tap F, I could kind of zoom in on that. And we've got the unpause button right there, and then we have the main menu button. So once again, I could use my move tool, and I could just drag it down a bit. and place it right there. And once again, we would want to disable our pause screen so it doesn't show initially when the game starts, and it only turns on, when the game manager or the UI manager tells it to. Okay, let's enter play mode and try these things out, make sure they work. And I'll move around. I hit the escape key and pause. The pause screen comes up and it pauses the game. I could unpause that. And let's get hit a few times. Okay, I lost 1 life. I think I have 3 lives total. So I'll get hit a few times here. Got hit again. And then on my third one, the game over screen comes up. Okay, and then we've got our main menu button. If I tap that, I get an error message down here in the console. Notice it says the scene main menu could not be loaded because it's not been added to our build settings. Okay, and of course we haven't added it to our build settings because we haven't created it yet. And that will be the topic of the next video. So for now, let's go ahead and stop playing and let's save our scene. Our level 1 UI is now mostly set up, but we also want a main menu in our game. In this video, we'll set up the main menu within a new Unity scene. So let's go over to our scenes in the assets and actually right-click on the _scenes folder. And let's go up to create and choose scene. And this will make a new scene. I'm going to go ahead and name it main menu, no spaces. So we have our scene created now. The first thing I'll do is actually add it to our build settings. So if I go up to File, Build Setting, you can see that we actually don't have any of our scenes in here yet. We just have the original sample scene that's been deleted. So let me go ahead and select that and hit delete on the keyboard to remove that scene. And I want to bring in both of my scenes here. So I will drag in main menu and I'll drag in level 1. Now the order matters because the first one is what will open when you start the game from a build. So we want the main menu scene to open first. So we put that first. And then eventually the main menu scene will call other scenes like level 1. Okay, let's go ahead and close our build settings because we're not actually doing a build now. We're just setting up what scenes to have in the build. Now within level 1, if we hit play again, and I'll just hit escape to speed this up. I've got my main menu button here. If I tap it, remember we got the error before, but this time when I press it, it actually loads the main menu scene. And of course we haven't actually designed it yet, but it actually does load that scene and we don't get that error anymore. So let me go ahead and stop. Notice we switch scenes, but when we stop, it actually reverts back to the scene that we were in prior to playing. So to actually build our main menu scene, we need to switch into our main menu scene. So let me double click on main menu and that will load it. And to speed this up a little bit, we have provided a prefab. So within prefab's UI, we have a main menu prefab. So go ahead and just drag and drop this into your hierarchy. And this will give us a complete main menu to start building off of. And let's just go ahead and enter play mode to check it out. Okay, so here we are in our main menu. You can see we've got a custom cursor here, not the regular mouse pointer. And we can click on level select, and there's a level select screen. Go back to main menu, click on instructions. There's sort of a blank instruction screen. Go back to the main menu, and let's click new game. And this actually loads that level 1, and we can, of course, play this. I'll just get hit 3 times maybe. And we get the game over screen. And let me go ahead and click main menu. And it goes back to the main menu scene. So we're getting most of our game loop implemented now. Let me go ahead and stop this. Now you will have to press escape to give focus back to the editor first. And then you get your regular mouse pointer back and you can hit the play button to exit play mode. Now if some of your buttons didn't work, it may be that you didn't name the scenes properly. So the code is set up to go from main menu spelled like this to level 1 spelled like this. So if you put a space in here or something, it wouldn't work. Another possibility is you forgot to add your scenes to the build settings. So make sure your scenes are in the build settings. Now, this main menu prefab doesn't cover everything that we want in our main menu scene, but it gives you a nice starting point for expansion. In interest of not repeating ourselves too much, we'll leave out the details of how this prefab was set up and a detailed discussion of it. But of course, you can hopefully now explore the sub-objects here and understand how it's all put together. I do recommend you take the time to familiarize yourself with how it's set up. So for example, if you click on the cursor changer game object here, notice that that is what is changing our mouse pointer to a custom reticle. And of course, you can see it says reticle 3 here. If I hit the target, we probably have additional reticles that we provided. So you can select a different one. Or, if you just want the normal mouse pointer, you could just disable this game object and then that would not run and we would just get the default pointer. Okay, but I'll leave that back on and I'll go ahead and save this main menu scene. Our game is nearly playable, but we don't yet have the ability to win the game. Let's address that in this video. So if you're in the main menu scene, go ahead and switch to the level 1 scene. And if we actually enter the play mode, notice that in the console, we actually get a warning message. If I tap on this, it says there are 10 enemies to defeat, but only 1 enemy found at start. The level cannot be completed. So once again, we wrote our scripts in a way to kind of detect common issues and output messages into the console. So this is one of those such messages. So let's go ahead and close the console and stop playing. If we go to the game manager, notice that we have enemies to defeat set at 10. And of course, we only have 1 enemy in our scene. We can resolve this in a couple ways. We could add more enemies, or we could reduce the number of enemies to defeat in the game manager. We're actually going to do both. So within the game manager, let's change that enemies to defeat from 10 to 3. So we'll have 3 enemies to defeat. And now let's go ahead and add some more enemies to our level. So within prefabs, you can see we've got the enemies subfolder. Let me open that. And one of the type of enemies that we have is the chasers. So we used a stationary shooter previously, but let me open up the chasers and you can see we've got 3 different chaser enemies. And let's grab 2 of these and bring them out there. I'm going to grab the diagonal chaser, drag and drop it out there. And I'm going to also drag out the chaser enemy. Okay, and they're placed right on top of each other. Let me go ahead and tap F to zoom into them. And once again, I could position these using the move tool. Maybe I'll kind of set up the 3 of them in a row at the top. Something like that. And let's enter play mode once again. And we've got 3 enemies now. You can see the chasers are actually chasing me around. Let me shoot those guys, and I'll shoot the 3rd one here. There we go. We get a level complete. And there's a next level button, which if you actually look at how that's set up, it actually goes to the main menu now. So if I press this, it'll go back to the main menu. Okay, let's go ahead and stop. And now notice if you click the play button, it might not let you stop. You might have to hit escape first, and then you get your regular pointer back, and then you can hit play to stop. Okay, we have the game manager set up now, so let's go ahead and save our scene. One last thing for us to do is to make a prefab out of our canvas, because our canvas is, once again, the UI in-game, and that's kind of all set up now. Since we always want the event system game object as part of our canvas, I'm actually going to drag and drop the event system just into the canvas. It's not actually a visible element, it's just a functional element. So now it's a child of the canvas. And I'm going to go ahead and rename my canvas to in-game UI. So it's got a logical name. And then I'm going to turn this into a prefab by dragging it into the UI folder under the prefab folder. So once again, in our prefab folder, we've got a UI folder, and I'll go ahead and just drag in the in-game UI right there. And now I've got a prefab created for the in-game UI. And let's go ahead and save our scene. You may have noticed that our game feels a little empty because it's very quiet, beyond a few sound effects. Music is an important aspect that adds to a player's enjoyment of a game. In this video, we're going to add 2 music tracks, one to play in our main menu and one in the game levels. So let's go ahead and start in our main menu. I'll double click on the main menu scene to load it. And I'm going to start by creating an empty game object within the main menu. So I'll hit the plus here and create empty. And I'm going to name this my main menu music. And I'm putting it on its own game object just so it's easy to find. Of course, you could put it anywhere, like the main camera, for example. But with my main menu music game object selected, I'm going to go ahead and add a component to that. And I'll start typing audio, and you should find the audio source component, which once again, that's how we create audio sources in our world. And we've actually provided some audio for you. So let's go ahead and find that. I'll close the prefabs here and open audio. And we've got various sound effects, but let's look at the music. And you can see we have a menu song here. So if I actually click on this, once again, we can bring up the inspector. At the bottom, we can pull this up and we can preview this. Okay, so let's go back to our game object and drag this and drop it as the audio clip for this audio source. And this song is meant to seamlessly loop. And if you're just sitting on the main menu and you don't loop it, it will play once and stop, okay, which isn't the best experience for your player. So I'm going to set this to loop. And since this is music that we want to play at a fixed volume, we will keep the spatial blend at 2D. You can, of course, adjust the volume property of the audio source to change the actual volume of the music if you wish, but we'll just stick with the default of 1 or full volume. So now if we actually press play, we should be able to hear our main menu music, and because we set it to loop, it should play forever. Okay, let's go ahead and stop this and save our main menu scene because we've got music there now. And let's go ahead and open our level 1 scene. Now here we're going to basically repeat the same process. So I'm going to go ahead and create a new empty game object in the hierarchy. And I'm going to call this my game music. And I'm going to add an audio source component to that. And I'm going to target an audio clip. We provided 3 songs that you can pick from. I'll just go ahead and choose song A. And of course, you could preview that as well, like we did for the menu song. And these songs are all designed to loop as well. So we want to set it to loop so it doesn't end, while we're playing a level. And with that set, we can go ahead and hit play here. And we can hear that music playing. And it definitely adds to the, excitement of playing this level. Okay, and we'll go ahead and stop that to exit play mode. And let's go ahead and save this scene. Now we should have music set up in both our scenes. Just like that, the game is much more engaging. In this video, we'll go over how to add more levels to the game. So let's start by opening the main menu scene once again. And I'll close up some of my other folders here. Now, if you open the cascade on the main menu game object, you can see we've got a canvas here. If I open that, we've got various screens. Right now, we're actually looking at the main menu, but let me open up the level select, and that has various buttons here. So let me actually disable the main menu. So that goes away, and let's enable the level select so we see what that looks like. And you can see when I enable that, it's got the level 1 button turned on. If you select on that and look at it in the inspector, scroll down here, you can see that it set up the actual button component with an on click. And when we click, it targets the button itself. And on that has a script called a level load button script. And we pass the name of the level to load. In this case, level 1. Now you can see we've got 2 other buttons here, one for level 2 and one for level 3, but they're disabled by default. So let's go ahead and select level 2 and enable it, turning it on. So you can see there, level 2 shows up. And once again, in our scene view, we can tap F to zoom to that if we wanted to see it in the scene view. And once again, if we scroll down on the button itself, you can see that it targets that same level load button script down here, and it specifies level 2 as the scene that it should load. So now we can quickly load a level 2. Of course, there's a level 3 that we can also turn on, and if you wanted a 4th or 5th level, you would just duplicate one of these buttons and make the necessary changes. So let me go ahead now that I've got that level 2 turned on, and I'm going to go to its parent, which is the level select. And of course, I don't want to show this initially, so I'll disable that. But I do want to show the main menu initially, so I'll re-enable that and get back to the way we were. And let's go ahead and save our main menu. So to add more levels to our game, we need to first create scenes for them. If we don't want to start completely from scratch, we can duplicate an existing level in the project folder. So of course, we've got our level 1 scene here, and I could basically use that as a template. So I'm going to go ahead and duplicate that. So I can hit Control D on Windows or Command D on the Mac. Interesting enough, here on Windows, if I right click on this, for some reason there isn't actually a duplicate option here. Okay, so, but you can duplicate by using the hotkey. Okay, so we've got a level 1 and then a level 1 space 1. So obviously we want to rename this. So let's go ahead and rename this one as level 2. And once again, our button that we set up here, our level 2 button, is set up to go to the scene named level 2, no spaces. Of course, now that we have a level 2 scene, we need to include it in our build settings for it to work, when we do a build, but it also needs to be in there even when we test in the editor. So let me go to File, Build Settings, and let's just drag and drop the level 2 scene into the build settings. So we've got all 3 scenes here now, and I'll close that. Now we need to add our level 2 to the rest of the gameplay loop. So if you remember when we made our gameplay loop the first time, our level 1 just cycles back to the main menu when you beat it. So we need to change that. So let me go into level 1 and then look at our in-game UI, and let's look at our level victory screen because that's what pops up when you beat the level. And if I cascade it out, you'll see the next level button. And once again, if I look over in the inspector for that and go down, you can see that it does that level load button command where it's going to load the main menu. So in this case, within level 1, when I beat level 1, rather than go to the main menu, I now want to go to level 2. So I'll do an override on the prefab there to go to level 2 rather than the main menu. And of course, level 2 was based on that original prefab. So when you beat level 2, it'll go back to the main menu. Now, if down the road you added a level 3, you would need to go to level 2 and change this next level button to go to level 3. Okay, let's go ahead and save our scene here. So our level 2 should now be in our entire gameplay loop. So let me go back to the main menu and hit play. And if I go through and hit new game, it should show load level 1, and you can see that up at the top of the menu, that I'm in level 1. So let me try to beat this quickly. Okay, we get the level complete. Next level, let me tap on next level. And of course it's going to look the same because we just duplicated it, but now I'm in level 2. You can see that up there. And I can beat this level quickly. And when that comes up, if I hit next level, it should go back to the main menu, which it does. Now, we should also check our level select. So let me go into that. You can see now we have that level 2 button there. If I tap on that, it should go right to level 2, which it does. Okay, let's go ahead and exit play mode. Our complete gameplay loop now works with both levels in. Of course, the level is just a placeholder for our demonstration. As you expand your game, you would want to go back to your level 2 and make it different from your level 1. Text Mesh Pro is a newer text rendering option for Unity. It brings a lot of powerful options to the display of text. In this video, we'll use some of these options to further adjust our text within our game's user interface. Let's start by opening the main menu scene if you don't already have it opened. Within the hierarchy, open the main menu game object and find the page title text. It'll likely be within the main menu canvas, main menu, UI backdrop, and right here is the page title text. Now, if you look in the inspector, you'll notice that the text component shown here is actually a Unity Legacy text component, not a TextMesh Pro text component. Therefore, there are a lot less properties that you can manipulate on these components. And honestly, they don't look nearly as good as the TextMesh Pro components in-game, as you can see down here. Let's replace this game object with the TextMesh Pro version. If we right-click on the UI backdrop game object, we can go down and select UI, and notice there's a legacy option, and these are the legacy UI options, and that's the legacy text. But of course, we actually want to choose the text-TextMesh Pro option. Let's go ahead and do that, and we'll rename this as the main menu title. And I'm going to drag and drop it just below the page title text. Okay, let's copy the text contents from the page title text. So where it says Space Blaster, I'll select that and just copy. That's Control-C on Windows or Command-C on the Mac. Or of course you can go to the Edit menu and choose Copy. And I'll come down here and I'll paste. Control-V on Windows or Command-V on the Mac. And we get Space Blaster there. Let's go ahead and change our font asset to the Mana Space font. And let's also change the font size. If you notice on the other one, it's set to 19 point font. So let's change this one to 19 as well. And the other one is black. So let me change the vertex color here. And we'll choose black. And if I scroll down a bit, let's change the alignment to be centered. And let's change the top middle down alignment to be middle. Okay, so then it will be in the middle of this yellow text box. Now we need to position this game object in the same location as the page title text game object. These settings for UI objects are contained within the rect transform component at the top of these game objects. Now, if we actually go to the page title text game object, and look at the rect transform, we can see all the settings here, and you can copy and paste these individually, but that would take some time. So if you click on the ... menu here for this component, we can go down and choose copy and then pick component. Now if I go to the main menu title game object now, I can do the same thing and click the ... under the rect transform component and go down to paste and choose component values. And by doing this, it will paste all the values for that component immediately in one step. Okay, so we have our new version set up, and if you deactivate it, you can see the old one looking at the game view, and then the new one, old one, new one. You can see it's quite a bit bolder for one thing, and overall just looks a little bit better. So now with that in place, I can go back to the page title text and right click and then delete that. So we have just the main menu title now. And of course, this was a modification of our game object that's based on a prefab. So if I go back to the main menu at the top, you can see the little blue bar here showing that the prefab was modified. And if I wanted to apply this change back to the prefab, I can select here and see the prefab that it's modified off of, and then go to overrides, and I can see all the overrides and maybe apply all, but in this case, maybe I just want to apply these two. So this is the creation of the new main menu title. I'll go ahead and apply that to the prefab, and then the deletion of the page title text, I can apply that one, and I'll leave all the other settings alone because some of those maybe were things that we wanted just in this scene. Now the text on the buttons that you see here are also old legacy text. I'm not going to update them now, but feel free to do this on your own if you so choose. But for now, let's move on. I'm going to go ahead and save this scene. and I'm going to open up my level 1 scene. And let's locate our score text that we can see here. And you can always click on things in the scene view, and that's one way to kind of quickly find it in the hierarchy, if you can actually see it in the scene view. So I've got my score text selected. One thing that you may have noticed is our score text display actually wraps when we got to 10 points or above, because the size of it wasn't quite big enough. So when we got to that, second digit, it actually wrapped down to the next line. Now there are a few ways to actually resolve this issue. One simple way is just to expand this box. So we can just drag it and make it bigger. And if you recall, we did this for the high score text display back when we first created it. But it's hard to sometimes predict how large text contents will become. In this case, how big the score might become as a player plays the game. Of course, you could just make it very large and then, it's never going to exceed something like that. But there are other ways to resolve this issue. I'm going to go ahead and undo Control-Z on Windows or Command-Z on the Mac, just to get back to where it was for purposes of example. So another way to resolve this issue is to simply reduce the size of the font. So once again, if we look at our Text Mesh Pro options, you can see the font size is set here to 36. So I could just make this, a little bit smaller, maybe down to 30. Then when the score gets bigger, it's going to fit smaller. So if I change that to 30, you can see it got smaller within that text box. Okay, I'll go ahead and undo that. But notice there's an option right below called auto size. And if I select this, it gives me 2 additional options. Now they may be small, so I'm going to actually expand this out so I can see them better. And you can see I can specify a minimum font size and a maximum font size. And notice when I clicked auto size, it set the font size from 36 to 42.1 because it could actually expand the size of this. And as I play the game now, let's pretend that I get something like, 10, you can see the font size change there. And if I got to 100, it's going to get smaller, 1,000, smaller yet, and so forth. So this is automatically changing the font size between 18-point font and 72-point font, okay, to fit within that text box. So auto size is a nice feature provided by Text Mesh Pro to basically dynamically scale your font based on the contents. Now, if I got very, very large, eventually it will get down to 18 point. And if I go beyond that, then it's going to still wrap, as you see there. So this does, fix the issue for all reasonable purposes here, but doesn't completely fix it, for some applications where the text may expand large. And of course, this may not be the aesthetic that you want, basically having your text size dynamically change over time. So let me go ahead and turn off auto size and go back to 36. And of course, we see it wrap many times here. So if you scroll down a little farther toward the bottom, you can see there is a wrapping option. And currently it's set to enabled, which basically means that if it expands beyond the size of your text box, it's going to wrap. Okay, if you click on this, you can disable that, and look what happens. It actually doesn't wrap. It expands beyond the bounds of the text box. Okay, and you can actually adjust the overflow settings. So the top option is actually overflow, which allows it to just overflow outside of the text box. I'm just going to stick with overflow for this purpose because this actually solves my problem. And of course, my text is never going to be this large in this game. It might only get up to something like 100. And you can see that our font size is maintained and we don't wrap. Okay. And of course, I want to set this back to score:0 for when the game starts. Okay, now if we actually play again, and try to shoot these, notice that when I get to 10 and above, it doesn't actually wrap. So that essentially solved my problem. Okay, and let's go to the high score text and let's enable the same thing. So going down to wrapping, we will disable wrapping and just make sure the overflow is set to overflow. So if the high score gets large beyond the size of this box, it will overflow. And once again, I made this box very big when I first created it. You know, if I went ahead and shrunk this down to maybe about the same size as the score, it'll be basically the same. So it won't wrap when it hits the edge of this. But of course, you could use a combination of the three approaches I just discussed to deal with similar issues in the future. For now, we'll stick with these overflow settings. Now, Text Mesh Pro actually allows you to specify HTML style tags within your text content to further enhance the display of text. Using HTML tags, or what Text Mesh Pro calls rich text, is a powerful way to enhance your text. To demo this, let's actually activate our level victory screen game object. So remember, we have these three screens. They're disabled by default. So let me enable it so we see the level complete. And let's add some markup tags to this text. Okay, so if I go within it and find the victory title text game object, this is where my Text Mesh Pro text component is. And I'm going to add some markup here. So HTML tags, begin with a less than sign, then you put the tag. I'm going to use a B to make it bold. And let me go to the end of the level and do another less than sign, and then a /B, and then a greater than sign to end the tag. Okay, it's a little hard to tell with this font, but you can see that we bolded the word level here. And then complete is not bolded. Okay, so if we wanted to have part of the text bolded and part of the text not bolded, without this ability, we would actually have to have two separate game objects, one for the first word and one for the second word. But we can expand on this. We can actually add another tag. So under complete, I'm going to write color equals, and then in quotes, I'm going to write green, in quote, and then greater than sign to end that tag. And then at the end of this, I can go ahead and end this color. So I can do a /color, which will change it back to black if I type any more text. Okay, but we'll just go ahead and leave it like that. Overall, support for rich text is a powerful feature. You can check out the Text Mesh Pro documentation on rich text to see all the tags and features supported. Okay, so we made a little modification there to our title for the level victory screen. Let's go ahead and disable the level victory screen. So select it there in the hierarchy and then disable it at the top of the inspector. Now let's activate the game over game object. Okay, so this is our game over screen. And notice this text is a little hard to read where it says game over. So let's find that game object with the text on it. So I'll go ahead and open this, open the UI backdrop, and there's my game over title. If you recall earlier, we created a Text Mesh Pro compatible font asset from a TrueType font to create the ManaSpace SDF font that we've specified right here. Now, just below the font asset is a material preset. The material preset is a material that controls things like outline, shadows, and lighting for your text. The material is typically created when you create the Text Mesh Pro font. You can see it's currently set to ManaSpace Atlas material. Let's actually create a new material that changes the look of this font. Now, if you navigate to where you created your font asset, I'm going to go ahead and expand this back a little bit. And if you recall, that was in Art, and within UI, there is the font folder. So make sure that's expanded, and then expand the ManaSpace folder. And within that is the ManaSpace SDF font asset. So I'll go ahead and expand that. And right here, we've got a font asset material. So go ahead and select the font asset material, the one that has the little sphere icon. Now with this material selected, I'm going to go ahead and duplicate it. So I'm going to use Control D on Windows or Command D on the Mac. This will create a new material. Notice it placed it outside of the font, which is fine. I'm going to go ahead and rename this. So I'll change it from ManaSpace Atlas Material to the same thing, and I'm going to put -outline because this is going to be an outline version of that material. Now notice we've got various settings here. One of those is an outline setting, and there's a thickness setting down here. And I'm going to go ahead and just set this to something like 0.25. And notice there's other settings for underlays, lighting, glow, and so forth. But just for purposes of example, we'll just change the outline. Now, if we go back to our game over title game object in the hierarchy, once again, under the Text Mesh Pro text object, we've got the material preset. And if you click the drop down here, you can see that we have the outline version as an option now, since we've just created it. So I'm going to go ahead and select that. And notice what it did. It actually has a little outline on it in black. Okay, and with that now set, I can go back into the material and I could, maybe expand the thickness a little bit. Maybe make it to 0.5. You could change the outline color. So if you don't want it pure black, I can make it, whatever color I want. I can make it white. I'm just going to go ahead and leave it at black. And, once again, maybe bring the thickness down to around 0.3. Now, once again, you could go in and expand and play with some of these other settings if you wanted to. But I just wanted to show creating a new Atlas material and then specifying that within the Text Mesh Pro material preset. Now, if you scroll to the bottom of this, notice there's also settings here that you can change. But if you actually change the material settings here, it's literally the same settings. It will change it for everything that this material is on. So once again, if I went to a different object like the main menu text here, and I changed it here, it's going to apply to every single thing that uses this. So if I change it here, notice it applied it to the main menu and to the score and high score, which I don't want to do that. Okay, I just wanted to have a separate version, separate material, which is now on, the game over title. Now for this version, if I change this, it's going to just change it here and anywhere else that I've got the outline material set. I'll go ahead and undo back around, 0.3. Okay, let me scroll back up and let's look at a few of our other Text Mesh Pro settings here. Now, the font style settings are pretty obvious. You can bold things. So maybe I like a bold for game over there. And you can italicize things, of course. You can underline them. You can have a strike through if you wanted to. The next ones are kind of nice. You can do all lowercase. So notice I got a capital G and a capital O up in the text content, but this renders all lowercase. Or I can all uppercase. Or I can small cap. So this will make the first letter capital, and then rest of them capitals, but smaller versions of that. And I kind of like that for, the game over here. So I'll stick with that. And of course, we already looked at font size. In the case of here, maybe we want to dial this up a little bit so we have a larger game over shown. And once again, it should be within that yellow box. And if it's not, we need to either auto size or we need to set wrapping options. Now, vertex color sets the color obviously to red, but we can actually use a color gradient rather than a single color. So let me actually turn this on, and this gives me a variety of color gradient settings, including the color mode. If I select the color mode, and I'm going to pick a vertical gradient for purposes of example, you can explore the other ones if you wanted to, but let me choose vertical gradient. And this has me specify two colors. The top color would be the top color on the font in the vertical gradient, and then the bottom color is the bottom color. So it's going to do a gradient between this color and this color. Now, the reason it's still red is because it actually applies this sort of as an overlay on top. Now, let me go ahead and go into the first color, and let me just pick, a red again, like a bright red, and go to the bottom one and pick maybe a dark red. Okay, and you can see the gradient effect rendered there in the game view. And once again, feel free to play with some of the other color modes and see the different effects that you can get. Now, the next set of options are the spacing options. This allows you to have finer control over how much space there is or isn't around your text, between characters, between words, between lines, or between paragraphs, which overall is a lot of control in terms of how these things are rendered. And of course, we have the alignment options that we've already looked at and used. Now there are several additional properties or settings that you can adjust to customize the look of your UI text. You can of course reference the online TextMesh Pro documentation to learn more about these settings. As you can see, TextMesh Pro gives you great control of how your text is rendered. Now, as a final step, I want to go back to my game over screen and deactivate it because I don't want it on when the level starts. And let's go ahead and save our scene. In this video, we'll discuss finishing up your 2D shooter project. Your objectives will be to back up the tutorial project, expand and modify the project to make it your own, gather screenshots, create the final builds, compress the builds for distribution, publish the game on the internet, and provide the URL to the location of your game for assessment. Okay, I demoed several of these steps in detail in the Solar System project, but let me give a quick review while spending a bit more time on some new things. The first thing I want to do is create a backup of my tutorial project before I get into the modifications. Now, if in our file system, we navigate to where our Unity projects are, we should have our project folder here. In this case, it's the 2D shooter folder, and I'm going to go into that. And when you look into your project folder, you should see assets, library, logs, packages, and various other things. Once again, if you see this temp folder, that means your project is currently open in Unity. So let me just go back to Unity quick and actually close the editor. And when I do that, that temp folder will go away. It probably doesn't hurt to include it in your backup, but just to show that when you do exit, it does get rid of that temp folder. Now to actually make a duplicate of a Unity project, we duplicate the entire folder. So once again, I'll go back to my Unity projects level, and I'm going to right click on this and choose the copy operation here. If you're on a Mac, if you right click, there's actually a duplicate option, so you can just select that directly. But I'll copy this, and then over here, I will click the paste operation here in Windows 11. And this is going to paste that folder that I copied, making an additional copy. Okay, now I can rename this folder. It just defaulted to 2D shooter-copy. Let me rename this to 2D shooter tutorial, just to keep it straight. Because this is going to be kind of a frozen in time version, and the other one will be the one that we keep working on and doing our modifications. So if we go back to Unity Hub, once again, we should be able to open our current active project here. And if you ever want to get back to the tutorial version, you'll need to add it to the list here. So we can click Open and then navigate into that and then open it. And then it will add the tutorial here to our list of projects. Okay, and this will actually load it into the Unity editor, which I don't want to do. So let me just close the Unity editor once again and go back to Unity Hub. And once again, if you don't want a project in here, you can click the ... here and just remove the project from the list. Now this doesn't actually remove it from your file system, it just removes it from Unity Hub list here. So it's sort of the opposite of going up to open and adding it to the list. But we'll leave the tutorial in the list. Just make sure that you're selecting the right version when you're making your modifications. So in this case, I want the 2D shooter project, not the 2D shooter tutorial. So I'll go ahead and select that in Unity Hub to launch the Unity editor. The next step is to do the modifications to the project over and beyond the tutorial, as defined in the assignment. Take the time to look through all the assets that we provided here in the project. There are a lot of additional art assets, prefabs, and scripts that you can use or modify off of to enhance your game. And of course, you can also create your own assets and import them into the project. The modifications you do can focus on art, design, or programming tasks, or you can mix and match across disciplines. Try to really make the game unique, make it your own, and try to entertain your potential players, as well as impress your peers. It may take some time to implement and test your modifications, so give yourself ample time. For demoing purposes, I'm just going to pretend that my modifications have been made and continue on with the finishing up steps. In the assignment, it asks you to include screenshots of your game. There are a number of ways to get screenshots, as we discussed in the Solar System project. However, we're getting screenshots of game footage. I've provided an elegant way to do this right from within Unity itself in the form of the screenshot utility prefab that we've included in the project. Let me demo that quickly. So within prefabs, there is a utility folder, and within that is the screenshot utility prefab. Okay, and this prefab is basically using the same script that we used in the solar system project, this screenshot utility script. Okay, so I'm in my main menu scene, which is the first scene that loads, and I'm just going to go ahead and add the screenshot utility prefab here. And this prefab is set to run only in the editor, so when we build later, it won't actually, allow the user to make screenshots. It will only work for you in the editor. Now, we can set a screenshot key here. Since our game is actually using the WASD keys, including the S, we actually overrided the screenshot key from the default of S to C. And you can make that whatever key you want, but we'll just stick with C here. And let me go ahead and play. Okay, and there's a few things that I want to do. I want to set my game view up properly. So right now it's just in free aspect ratio. I'm going to click down here. Generally, when you're grabbing screenshots, you want to pick a specific resolution. And there's some predefined defaults here. One of those is full HD, which is 1920 by 1080. And that's actually what I want. So I'm going to select that. And if I wanted something different that's not here, I can click the little plus here and I can, actually set an XY resolution that I want and give it a label and it will add it to my list. I'm not going to actually do that now, so I'll just cancel that. So once again, I picked the full HD 1920 by 1080. Now within the game view, even though it's small here, you can see it's scaled down. My screenshot utility will actually grab the full resolution 1920 by 1080 screenshots that I want. Okay, and of course I could maximize this if I wanted to, but there's no real need to. So I'm just going to hit the C key once right here on my main menu to grab a screenshot of my main menu. Notice down in the console log, it told me that it captured a screenshot and where it saved it. I'm going to go into a new game now and start the game, and I'll fly around a little bit and then hit the C key again and then try to shoot, and maybe during some action hit the C key a third time. And I've got 3 screenshots created, which is enough for the demo. So let me just stop that. And the screenshots will be saved in a screenshots folder within your project folder. So if we go back to the file system and go into our 2D shooter project, notice there's a new folder called screenshots. And within that, there should be those 3 screenshots that I just took. Okay, let's go back into Unity. And the next step is to create builds of your project for the desired target platforms. Likely you'll be building for Windows, Mac OS, and WebGL. So to start with, we go to the File and go down to Build Settings. The first thing that we want to do is make sure the scenes in the build are set up properly. So we want all the scenes that we want to include in our build here. And in this case, I have the main menu, level 1 and level 2. If you had additional levels or additional scenes, you would include them here just by dragging them out of your project scenes folder into the list here. The next thing is to define what platform we want to build with. So we'll start with the Windows, Mac, Linux option here. And over on the right side, we can pick our target platform. So right now we will target Windows, and I'll just leave all the others as the default. Now, before I actually click build, let me click on player settings. The player settings you typically want to do it the first time that you're setting up your project for a build. So once again, you could define things like your company name, whatever you want to put here. I'll put Michigan State University. You can set your product name. I'll just keep it as the default here. You can set a version number. Now you can also specify a default icon. If you don't specify a default icon, your double clickable application, your exe on Windows, will be the Unity icon. So it's always nice to customize this and choose something different than the standard Unity icon. Now in our assets, we provided an asset that you can use. Let me go ahead and click the target here and search for game icon. You can see that right there, and I'm going to select that. Now, of course, you could make your own icon. Notice this is a 1024 by 1024 pixel image. I do recommend if you make your own icon, you make a similar resolution of 1024 by 1024. Okay, I'll go ahead and close this. that's now defined. And if you open up the icons, notice it scales it down to various sizes. And if you wanted to, you can do an override for any of these sizes. Okay, I'm going to close that and look at the resolution and presentation. Now, the first thing to look at is the resolution. It says full screen mode. And we have various options here. You can actually build a game that would be in a window if you wanted to. But I generally like games to be very immersive, so a full screen window is probably the best option. The next is we can set the resolution. So if you leave this checked, whatever the user's resolution is set on their computer, the game will open in that. And depending on how you made your user interface, if it's whatever aspect ratio you made it for, if you made it completely scalable and responsive, will kind of go into this choice here. Now, if it's scalable and responsive, you could just leave this checked. If not, you probably want to uncheck this and then specify your default screen width and height. Okay, so if we did that and built for 1920 by 1080, this would be a standard HD resolution, a 16 by 9 aspect ratio, and I'm going to go ahead and go with that for this game. I'm going to leave everything else the default. And notice in our player settings right now, we're on this tab, which are the settings for Windows, Mac, and Linux. There are other tabs here, and one of those other tabs is HTML5. Okay, so these are our settings for WebGL. So we can actually set those right now as well. So one of those settings is the resolution and presentation. Once again, we can pick a default canvas width and height. Remember, WebGL will be in the browser, so we probably won't make it as big. We wouldn't make this 1920 by 1080. I'm just going to go with the default here of 960 by 600. And we could pick a WebGL template as well. And I'm just going to go with the default here. Now, one change to the default settings I do recommend that you make is under Publish Settings. So let me go down into that. And that is this decompression fallback. And this says include decompressed fallback code for building files in the loader. Use this option if you're not able to configure your server response headers according to the selected compression method. Okay, and we found when we put our projects in various locations, if we don't check this, they might not play back properly. So I recommend checking this option here in the player settings for the WebGL settings. Okay, our player settings are set up, so I'm going to go ahead and close this window and go back, and I want to start by building for Windows, so I'll set the platform back to Windows, and the target platform is Windows, and I'll go ahead and click Build. And we specify where we want to build. If you recall, within our projects folder, so at the top level of your 2D shooter folder, I would make a new folder called Builds. Make sure you're not placing your files within assets. That really confuses Unity if you put your build inside the assets folder. So I'm outside of my assets folder. At the top level of my project, I'll pick new folder, and I'm going to call this Builds, and I'll go into that Builds folder, and I'll create another new folder, and I'm going to call this Windows, and I'll go into the Windows folder and go ahead and select this folder, and this will start the build process. And of course, builds take some time, so I'll fast forward through the build process. Okay, our build for Windows is now created, and it opened that Windows folder where all of the files are in. This is our double-clickable exe. Notice the custom icon here. Now, if you're going to deliver this to somebody, you have to deliver all of the contents here, not just the exe. Okay, so just be aware of that. And let's go back to Unity and change our target platform to Mac OS. And since we've already set up our player settings, we don't need to go back in and reset up the player settings. But when you do switch platforms, sometimes it takes a few moments because it has to maybe re-import some assets and recompile some scripts. Okay, and I'll go ahead and click Build to build my Mac OS version. And just like before, I'm going to go into my Builds folder, and I'm going to create a new folder for Mac OS. And I'll go into the Mac OS folder and target that, and then do the build. Okay, my Mac OS build is built. For some reason, there's a bug in Unity where it doesn't target the folder properly. So the macOS.app is the actual app that's built. I'm going to drag and drop this into my Mac OS folder. The other one you could just ignore. Let me just right click on that and delete it. Okay, so within Mac OS, we've got our Mac OS app. You can rename this if you want to, so it wouldn't come up as Mac OS on Mac OS. So I'm going to call this my 2D shooter, just like it would show up on Windows. Now I'm actually on Windows recording this video, so I can't launch the Mac version. I would have to actually bring this to a Mac to test it. But if I go back to builds and go into Windows, I can actually double click on the application here to test it. So let me do that really quickly. And it will fire up with the Made with Unity, unless you've got the professional version of Unity. And I can go in and start a new game. Notice it's full screen, and I can play, finish level 1, go to level 2, which is currently the same, but of course you'll have different modifications. Hit the next level, go back to the main menu, and I'll hit exit game, and it should quit back to my file system. And it's always good to test your builds after you make them, just to make sure that they work properly. In purposes of this class, test on at least the platform you're on. So if you're on Windows, test the Windows build. If you're on Mac, test the Mac build. Okay, let's go back to Unity and let's make one more build. So we want to switch our platform to WebGL. So let me select that and choose Switch Platform. And once again, when you switch platforms, it might take a few minutes to actually convert over to the new platform. And notice we get the little warning here that we can't build while the editor is importing assets or compiling scripts. So we have to wait a few more moments while this process completes. You can see the little spinning wait symbol down here. So we'll wait a few more moments. Okay, we've switched platforms now and we're ready to build. Now, if you build WebGL, it will build all the files that you can deliver up to itch.io, but you actually can't test it locally because of local security restriction. So if you actually want to test a WebGL build locally, you have to click build and run. And this works in conjunction with Unity servers to allow you to actually test it locally. So I'm going to go ahead and do that. I'll click build and run. And once again, we can select where we want to build. Let's go into the builds folder and we'll make a new folder for WebGL. And I'll name it WebGL. And I'll go inside of that folder and target that. And we'll go through the build process for WebGL. Okay, my WebGL build is now done, and because I selected build and run, it actually opened in my browser, so I can actually test it right here. And once again, hit new game, go into the game, go through each of the levels here, and back to the menu. Now, if you hit exit game, it won't actually exit because I'm in the browser. Okay, let me go ahead and close my browser. And if I go to my file system and go into my builds folder, notice we have the WebGL build folder. Within that, we've got an index.html and then a build folder and a template data folder. Now, just like the other builds, we need to include all of these materials if we want to distribute it or test it. So the next thing is to prepare our builds for distribution. So the way we do that is go back to your builds folder. And for each platform, we need to create a zip archive. So the way we can do that here on Windows is if you right click on a folder, so I'll start with the Windows folder, right click, I can choose compress to zip. Now, if you're on a Mac, it's a very similar process, just right click on the folder and select compress. And if I do this, it will go through the process of making a zip archive of that folder that I right clicked upon. Okay, so this is my Windows build folder. And I'll do that also for my Mac OS, compress to zip archive. And I'll also do that for my WebGL, compress to zip archive. Okay, so these are my 3 zip archive folders, not to be confused with the actual folders. And these zip archives are what I will distribute up on itch. So now let's distribute or publish the game to the internet, as we did in the Solar System project. So let me go back to my browser. And I'm going to direct it to itch.io. Now, if you're not logged in, go ahead and log in the upper corner. You should have created an account in the last project. If you didn't, you'll have to click register and go through the process of creating an account. Now, I actually did create an account. And if I click on my name, it will allow me to kind of go to my overall project tab here. And you can see I have the Solar System project here. And if I click on dashboard, this will bring me to my dashboard where I can see the projects tab and my projects here. And I'm going to go ahead and create a new project. So let me click the create new project button here. And I need to go ahead and fill out this form. So we can give this a title, whatever you want to call it. I'll just call mine 2D shooter. And this will create a project URL for me, which I can modify if I wanted to. I can give a short description or tagline, which is optional. You could do that. You can specify a classification if it's a game, which it is. The kind of project. Now, if you want your WebGL to play in the browser, you'll have to change this from downloadable to HTML. And this allows you to have, a version that plays in the browser and downloadable content for Windows and Mac. So that's what I want, is the HTML version. And for release status, I'm just going to go with the default of released, project's complete. And for pricing, we're going to say no payment for the class project. And then we need to upload our various builds. So if you ever have problems, make sure to read here, because this tells you things like your zip archive must contain an index.html file, for the WebGL build. So let me go ahead and upload, and I'll start by uploading my WebGL build. First, I need to navigate to my project. So within my Unity projects, I'm going to go into the 2D shooter and go into my builds folder. And then I want to select the zip archive version. So let me do WebGL first, and we'll open that. This will upload, and if everything is correct, itch.io should recognize that. And I'm going to select this file will be played in the browser. Okay, so that's my WebGL version. And then let's upload the Windows version. Once again, picking the zip archive for that. And for this, it's an executable, and I'll say it's for Windows. And then one last upload, we'll pick our Mac OS zip archive and upload that. And once again, this is an executable for the Apple symbol, which is for the Mac OS. And down below, we can set our embed options. How would you like to embed the project in the web page? You can play with these. I think my project was 900 by 600 in size, so we want to specify that accordingly for the viewport. And if you don't want to embed in the page, you can have a click to launch full screen, which is another option that you might want to set. Let me go ahead and scroll down. We can give a description. This is a great place to describe the modifications of your project. So I might just say something like, this is my 2D shooter project. I made the following significant modifications. Okay, so you would actually list your features there. And then I might actually add some credits here. And if I included any, third-party assets or things like that, I would list those here as well to give credit where credit is due. Now you can specify a genre and tags and some other things here. I'm going to just go with the defaults. And if I go back to the top, I can actually set up a cover image here. So let me go ahead and navigate back to the top level of my project folder, and I should have a screenshots subfolder. And whatever you want to do for your cover image, you could actually create your own cover image separate from a screenshot if you wanted to kind of theme your cover. I'm just going to go ahead and select a game screenshot here as my cover. And then I'll go in and add all of my screenshots. So I'll include my main menu and include my other two screenshots here. Once again, look at the assignment to see the specifics of what we're asking for. And I'll include 3 screenshots here in addition to the cover. So at the bottom, I could preview my page by hitting save and view the page. Notice I'm still in draft mode. And this will bring it up. I can see the big game view here. I can see my modifications. I can see my download buttons, but I can't see my screenshots. Once again, by default, Itch doesn't show screenshots. So we have to turn them on. So if you click Edit Theme, it will bring up this side panel where we can go down to where it says Screenshots and change these to Sidebar. Okay, so Screenshots to Sidebar. Okay, and then save that. And now the screenshots will show here on the sidebar. Okay, and you could also do additional theming here if you wanted to. But with those changes made, I'm going to go back and click Edit Game again to go back to the edit version. And at the bottom of this, if everything is correct, I will go from draft to public. And I generally like to configure my settings for class projects because I don't necessarily need the world seeing it. So I'm going to say unlist in search and browse. Now, if you are proud of your game and you want others to find it, you don't have to check this, and you could let people, find it just through searching and browsing, and they could provide comments on your game and all that fun stuff. So for now, I'll say unlisted in search and browse, and I'll save this. And this page is now created and ready to go. If I view the page, it comes up here, and this is the URL. Now, ideally, you should actually test your builds that you've uploaded. Test your WebGL and test your builds. Download. If you're on Windows, download the Windows version and just double check that it works. If you're on the Mac, download the Mac version. And on both platforms, you could test the WebGL. So with that done, this is the URL for my project. So I'm going to go ahead and copy this out of the browser. And you could go ahead and share this URL with your friends and family, post it to your socials and use it for the assignment hand-in. Congratulations, you've just published your 2D shooter game to the internet. The most important thing in the final step is to follow the instructions of the assignment in terms of the required modifications, what builds you should include, how to compress your builds, how to publish the project to the internet, and how to turn it in. Please reread the assignment while you go through these steps. I encourage you to strive to create something awesome, something that you're proud of, something that you want to show off to your friends and family. In fact, you should get as many people as you can to play your game during development to help you improve the game, and once you're done, to celebrate what you've created. In any case, best of luck in finishing up your project.
In this lecture, we'll discuss the big topic of programming in Unity. There are two primary programming methods in Unity as of Unity 2020. There is the traditional method of writing text-based code in the C# language. This has been the primary way to code in Unity for many years. A newer method of programming in Unity is through using a visual scripting language. In Unity 2020, Bolt Visual Scripting was added. There are several other third-party visual scripting tools available through the Unity Asset Store. And Unity plans to roll out yet another visual scripting language of their own in a future version of Unity. While visual scripting has the potential of making programming easier for non-programmers, it has more limitations over using C#, and it is still in flux within Unity. Therefore, in this course, we will focus on the tried and true method of writing C# code. I want to help non-programmers and programmers alike get into programming within Unity. Therefore, I'm going to attempt a balancing act to bridge between providing some foundational programming concepts for beginners while also discussing some Unity-specific concepts for everyone. If you are already a programmer, bear with me as I quickly cover some basics. If you are not a programmer, bear with me as well. Don't freak out or get nervous if some of these things don't immediately make sense. With time, effort, and experience, it'll become second nature to you. This lecture is just meant as a first step. Now, I want to speak with the non-programmers for a minute. I truly believe that everyone on the game development team should learn to program, from the traditional programmer to the designer to the artist. Programming is truly empowering. It unlocks the potential that you can solve problems yourself and build things on your own. If you cannot write code, you limit yourself to the will of others on the team. And if you don't have a team, you severely limit what you could do. Learning to program really helps you understand how games are made. From a designer perspective, it allows you to come up with ideas that are not only creative, but technically possible. From an artist perspective, it allows you to greatly expand your craft. For example, with programming skills, you can go much farther in tools like Maya, not to mention Unity. It also helps you communicate better with the technical team. If you can speak the language of the technical team, not only will they respect you more, you will also be able to communicate in a way that will make their job easier, which in turn makes your life easier. If you become a strong programmer, you open yourself up to many more jobs, including programmer, technical artist, technical designer, and level designer. Lastly, learning to program is very obtainable. I have found that many of my students that have struggled with programming in the past, when they get to programming within Unity to make games, something clicks in their brain and suddenly they get it. When it comes to programming, there are many levels of understanding. It takes effort to move to higher levels of expertise. This graph represents the learning curve, or the amount of effort it takes to move to higher levels of understanding. When you first start with a language, you have a very primitive understanding. This may be where you are right now with Unity and C#. You really have no knowledge of the language, but you may be able to use other people's code to get things working. But if something doesn't work, you're stuck. Next, we have a basic understanding. It takes a bit more effort to achieve this level of understanding. Here you have basic knowledge of the language. You understand the syntax and some basic commands. With this, you can probably write some basic scripts. You can borrow code and insert it into your own code. But unless it's very basic code, you might not really understand it. So if it doesn't work, you are stuck once again. The learning curve is the steepest while achieving intermediate understanding. Within this level, you grasp the core language. You can borrow code, understand it, and modify it. But you often must use example code to get started, or at least a good reference to create your own code. The most effort is required to move from intermediate to advanced understanding. With advanced understanding, you can generate complex code from scratch. You don't really need to borrow code or refer to a reference, except when doing something out of the ordinary. Going from advanced to expert usually just takes time and practice, not necessarily more effort. With expert understanding, you are proficient at writing quality code very quickly. You are the go-to person on the team whenever anyone has a question about how to do something. You understand all the intricate details of the language and the engine. In terms of programming in C# within Unity, your goal expertise level probably depends on your role on the game development team. As an artist, you should have at least a basic understanding of programming. As a designer, I recommend an intermediate understanding, given that you have to be more hands-on with the code and often work closely with the programmers. And as a programmer, I recommend trying to get to an advanced level ASAP and strive to become an expert over time. So what are our goals in this course? Well, first off, this is not a comprehensive programming course. If you've not programmed before and you really want to build your programming knowledge, I encourage you to seek out additional Introduction to Programming courses to complement what you're doing here. However, even if this is the case, I believe this course will be a good introduction to you. You may feel that things are a bit over your head at times. Don't be nervous, don't freak out. Just proceed on through the content. With time and practice, things will start to click. If you are a programmer but are new to Unity and game development, this course will be a great introduction to you. What we're going to do is introduce programming in C# within Unity. Our primary technique to teach programming is through a number of code walkthroughs that should introduce both beginner and seasoned programmers to the concepts of programming within the Unity environment. Finally, I will hopefully provide you with the resources you need to continue your learning beyond this course. Let's continue our discussion of programming in Unity by discussing the concepts of object-oriented thinking and how it translates into the Unity environment. Unity follows an object-oriented approach in the way it is structured and in the way that you write code. I like the object-oriented approach as I think it parallels the way we think about the real world around us. Everything is considered an object. For example, a clock is an object in the real world. It has properties such as its color, weight, size, and probably most importantly for a clock, what time is it? And it has methods or actions that you can do with it, such as the ability to set the time, the ability to set an alarm, the ability to snooze the alarm, and so on. This same concept could be translated into code. That is, in code, you could have a clock object that has a property or variable that we can reference to determine the current time. The clock object could also have methods or functions to set the time, for example. When building games in the Unity editor, virtually everything you're working with can be considered an object. The editor makes these objects visual. For example, the scene and the hierarchy view visually represents game objects. You can also consider the components that are attached to game objects as a type of object as well, with their own properties and methods, some of which are made visual through the Unity inspector. So, for example, this game object has a transform component. The transform component is an object that has position, rotation, and scale properties, as well as methods that you can use to translate or rotate the object. I believe that if you understand what is going on in the Unity editor, you are halfway to understanding code. One important concept in object-oriented programming is that of classes. Classes are templates for creating objects. For example, we could have an enemy class that defines how an enemy object works. We then instantiate or create objects from that class. The properties and methods of the object are defined within the class, but each enemy could override some of the defaults for the class. So, for example, the class could define the enemy as purple, while the objects derived from the class are set to green and orange. Prefabs are one way to visualize this concept in the Unity editor. That is, a prefab is a template game object. We can create many game objects from the prefab. While each game object has its own unique attributes, they are all based off of the original prefab template. To sum up object-oriented concepts, classes are templates for objects. Classes are linked in a hierarchy. So, for example, in Unity, there is an object class which is the parent of the game object class. You can create your own custom enemy class, which is a child of the game object class. A class can do anything its parent class can, and its parent's parent, all the way back through the class hierarchy. This is called inheritance. A class can override its parent's functionality to do something custom. This is called polymorphism. Objects are instantiated from a class. So if you want to create several enemies, you can do so by instantiating the enemies using the enemy class. And an object gets all the properties or variables and methods or functions that are defined in the class. This slide summarizes a lot of the object-oriented concepts and terminology that we'll use when talking about C# in Unity. So now that we know a bit about object-oriented thinking, let's dive into how to create C# scripts and their anatomy. From the Unity editor, you can create a C# script. C# is a popular, powerful object-oriented programming language used not only in Unity, but in many software development domains. As a programmer, becoming an expert in C# will serve you well career-wise, even outside game development. The script that you create becomes a game asset, just like graphics or audio files, and shows up in your project assets. You typically edit scripts in a tool external to Unity, such as one of the versions of Visual Studio. Scripts, when attached to game objects, become components of the game object and appear in the inspector, just like other components. Said another way, a script which defines a class is instantiated to become an object when it is attached to a game object. When you create a new script, Unity will give you a template script similar to this script. The using lines at the top just say that this script should use the Unity engine and system collections namespaces. That is, the namespaces should be part of the script. This just makes it easier to include references to code related to the Unity engine and the system collections within this script. If you are new to C# and this doesn't yet make sense, don't worry. Just keep the lines at the top that Unity automatically adds to your scripts and ignore them for now. The next line defines the class. The name of the class, basic target mover in this case, needs to be the exact same name as the file name for the script. If the class name and script file name do not align, you'll get an error in Unity. If you change one of the names, you need to change the other as well. The :mono behavior means that this class inherits from the mono behavior class. Mono is an open source implementation of Microsoft's .NET framework. Unity scripts are built on top of Mono. What this means is that if you're already a .NET programmer, your knowledge will apply to Unity. If you are not, you will build skills as a .NET programmer by programming in Unity. The behavior portion refers to a script that is attached to a game object. That is, if you want to write a script for a game object, it should inherit from the mono behavior class. Within the class definition, you define class variables, typically at the top of the class. These are often called properties of the class. And then you define class functions. These are often called the methods of the class. This section often is the meat of your code. You typically define variables within classes. You can think of these variables as properties of the class. When you define variables within a class, if you make them public, they appear as properties of the component within the Unity Editor Inspector. For example, here we define two public variables, one of type Boolean called doSpeed, which is initially set to true. This variable shows up in the inspector as a checkbox, checked for true or unchecked for false. The other variable is of type float called spinSpeed, which is initially set to 180. You can see that this variable also shows up in the inspector and can be changed within the editor from the default value set in the script. Notice how Unity changes the variable names into a more human-readable version in the inspector automatically. You can also create private variables that are used solely within the class. These are not shown in the editor by default. If you create a variable and do not specify it as public or private, it will default to private. Typically, you define functions within the class. Here you can see we have a start function and an update function defined in this class. These two functions are named as they are responding to events that occur in the Unity engine. For example, when we click the play button in the Unity editor, the start event occurs. If this script were attached to a game object in the scene, the Unity engine would call the start function on this script, and any other script with the start function within it. Every time the frame updates, an update event occurs. This will cause the update function to run, and it will run each time the update event occurs, which is typically many times per second. So overall in this script, the start function will run once when the game object first appears in the scene. And the update function will run over and over while the game object exists in the scene, typically on each frame update, which we call the game loop. So, as a quick review, this is the anatomy of a typical C# script, including the using section, the class definition, a listing of class variables, and the class functions. I know C# is new to many of you, therefore I want to provide a bit of a quick start guide on the language. This is where we dive a bit deeper into the technical jargon of programming. C# is an object-oriented programming language developed by Microsoft. It is a variant of C, a very popular programming language used for decades. If you have programmed in another language before, such as C, C++, JavaScript, or Java, the transition to C# will be an easy one. And many of the concepts I'll cover are available in most programming languages. Like I said before, if you're completely new to programming, I'm going to cover things quickly, as this is not a full-fledged programming course, but more of a quick start for those that have some programming experience, but may be new to C#. In any case, let's jump in. When learning a new programming language, first realize that you're communicating with a computer. You must be very precise. Putting a comma in the wrong place, or missing a semicolon, will result in what they call a syntax error. Therefore, you must understand the syntax of the language. That is, how the language is structured, so the computer will understand it. Once you have this down, then you can learn basic commands, the ones used most frequently. I'm presenting many of these basic commands across this lecture. It's also helpful to get a good reference to look things up. Fortunately, there are many available online. I'll point you to a few good ones. Also, it's always helpful to see code examples. I'll be showing several in this lecture and in projects across the course. And last but not least, practice. The more you program, the better you'll get at it. When you're learning any new programming language, it's traditional that the first script that you write is called Hello World. It is a script that simply outputs a Hello World message back to you. In C#, a Hello World script could look like this. If you attach the script to a game object in your scene and then click play, it would output the Hello World message to the console window within the Unity editor. The result would look something like this. You can bring up the console window by selecting Window in the Unity menu bar, then select General and then Console. Moving forward, you can use this basic script by just replacing the contents of the start function to test any of the code snippets in the examples that follow. The log warning, and log error methods of the debug class allow you to output messages to the Unity editor console window. The player will never see this information, but is very useful for a simple debugging technique while working in the Unity editor. Here are 3 more realistic examples of using debug.log. Here is the corresponding example output that you would see in the console window. Notice how we are combining a string with data stored in a variable name in the first 2 lines. The third line is using the floor method of the built-in mathf class to calculate the floor of a number. That is, it rounds the floating point number down to the nearest whole number. Okay, now that we can do something in C#, let's build upon that. There are several important things to realize in C#. First, C# is case sensitive. That is, you need to use the proper letter casing for things to work. So for example, debug.log with capital D and capital L is not the same thing as all lowercase debug.log. The one that works in Unity is the first line. Semicolons end a statement in C#, as you can see in the code above. You can have multiple statements on a line, or you can have a statement that spans across multiple lines, as shown here. It really doesn't matter in C#. However, most people only use one statement per line for human readability purposes. Speaking of readability, when writing code, you often want to add English comments to describe what you're doing in the code to make it more readable for yourself and for others. Single line comments begin with 2 slashes, while multiple line comments begin with a /* and then end with a //, as shown here. Anything that is included in the code that is a comment is completely ignored by the computer when the code is run. Once again, comments are only for us humans. With that said, it's always good to comment your code. Let's continue our quick start in C# by talking more in depth about variables. You can think of a variable as a little box that holds some information in the computer's memory, such as the number 25. You could then reference that information by a variable name, such as player health. So in this example, player health would equal 25, which perhaps is the amount of health points the player has left. During the game, the player may gain or lose health points. In code, we would use the player health variable to get or set the current player's health. Here are the C# rules for naming things like variables, names, and classes. Names cannot contain spaces. They must begin with a letter. They can contain letters, numbers, and the underscore character. They are case sensitive, so what letters are capitalized matters. And ideally, names should be descriptive, so the code is more human readable. When you create a variable, you give it a name. Variable names follow the rules that we just laid out for any identifier. For variable names, I like to use what is called lower camel casing, where you lowercase the first word of the variable name, and if you use multiple words within the name, you capitalize the first letter of each subsequent word to create logical, easy to understand names, such as player health, shown here. When you create a variable, you also give it a data type. The type defines what type of information the variable stores. Common types are integers or whole numbers, such as -1, 0, 1, 2, and 3, floating point numbers that have a decimal place, such as -1.45, 0.0, and 45.3. In C#, we add an F after the floating point number to clarify that it's a floating point number. Booleans that are set to true or false, and strings that store a combination of characters. Other data types that you encounter a lot in Unity are vector2s that store an X and Y position, and vector3s that store an X, Y, and Z position. Another common data type is a game object that stores a reference to a game object, or prefab. There are data types for any component. For example, an audio source type would be used to store a reference to an audio source component. We'll talk more about this later. You can also optionally set the access modifier of the variable to things such as public or private, depending on how widely you want the variable to be accessible. For example, a private variable is just available within the current scope of the code, such as within a class or function. A public variable is available outside the current scope. Understanding the scope of code is something that you will pick up on over time. If you don't set the access modifier, generally the variable is assumed to be a private variable. C# is a strongly typed language, which means that you must define the data type of the variable, such as string, integer, boolean, or float. You can assign the variables using the equal sign to literals as shown in the top 4 lines, or you can assign variables to the results of a function as shown in line 6. The variables we've been talking about so far are primitive data types. That is, they hold a single data value, such as an integer, float, boolean, or string. You can also create variables that are compound types that holds multiple data values. In C#, arrays and lists are compound data types that you can use. Arrays are great for storing predefined lists of related information. For example, if you want to store a list of family names, you could do so in an array. Here's an example block of code that creates an array. In the first line of code, we define a new variable. The data type is a string, but by putting the 2 brackets after the data type, we're saying that we want an array of strings. The variable name is family. We then set the variable to a new array of strings with a size of 5. This creates the array in memory. In line 2, we reference the first index position of the array variable using the 2 brackets with the index number of 0, and then we set it to the string Homer. Notice that the array starts at element 0, not 1. We say arrays are 0-based since they start at index position 0. In the rest of the lines, we set the remaining 4 elements of the array to the rest of the family members. There actually is a shorthand way to create this array, as shown here. In one step, we define the array and pre-populate it with the names. In this example block of code, we use the shorthand method to set up the array of strings in line 1. In line 2 and 3, we output 2 of the array elements to the console. Index element 0, which is Homer, and index element 2, which is Bart. Lastly, we output the total family size. We can get the length of an array using the length property of the array element as shown. There are several other properties and methods available to work with arrays. Lists are similar to arrays, but work a little different. In this block of code, I start by creating a list variable. The syntax is a bit different than arrays. I specify that I want a list, and then I put the data type, in this case string, between the less than and greater than sign. I then set the variable name to family and set it equal to a new list of type string. Notice we do not need to define the size of a list like we did for an array. A list can grow and shrink over time. In line 2 to 6, I add elements to the list using the add method. In line 8 and 9, I get elements of the list in the same method as we did with arrays, by specifying the index into the list between 2 brackets. And to get the size of the list, I use the count property, which is similar to the length property of an array. Just like arrays, there are several other properties and methods available to work with lists. Given that C# is a strongly typed language, you cannot change the data type implicitly. You must do so by converting the data. So, if you have a string that holds a whole number, you must convert it to an integer before doing addition and storing it into an integer variable, as shown here. The result of this would be 44 outputted to the console. If you have a string that holds a decimal number, you must convert it to a float before doing addition and storing it in a float variable, as shown here. The result of this would be 13.1 outputted to the console. And if you have an integer that you want to add to a string, you should convert it to a string before concatenating the string to the number, as shown here. The result of this would be score 100 outputted to the console. You also sometimes need to change between number types. So if you have an integer that you want to add to a float, you need to cast the integer to a float, as shown here. The result of this would be 15.4 outputted to the console. And if you want to go the other direction, that is, you want to convert a float to an integer, you need to cast the float to an integer, as shown here. The result of this would be 25 outputted to the console, since casting the float to an integer will effectively drop the decimal place. One thing computers are good at is manipulating data. When it comes to numbers, that means basic math. For example, we can do integer math with plus, minus, divide, and times. This example would result in 16 being outputted to the console window. Here is a similar example of floating point math. This would result in 13.8 being outputted to the console window. Note that C# follows the standard order of precedence we all learned in math class, where the innermost parentheses are calculated first, then multiplication and division, and then addition and subtraction within the current level of parentheses. So in the first example, the computer will do the calculation in the parentheses first, 5 minus 3, which equals 2, then multiply that by 12, which equals 24, which is stored in the variable x. Then y equals x divided by 2, or 24 divided by 2, which equals 12, and then add 4 to equal 16. Of course, the computer does all this for us, so we don't need to calculate it in our heads. And notice the difference between integer math and floating point math, particularly when it comes to division. There are a number of common math operations that you tend to do a lot in C#. There is a shortcut notation that you can use to perform these operations. So if you want to add the number 1 to a variable, you can use plus plus. Or you can use minus minus to subtract 1. You can also use plus equal to add one variable to another and store the result back into the first variable, or minus equal to subtract one variable from another and store the result in the first. Strings are another data type that we often want to manipulate in some way. We've already seen the use of plus to add two strings together. However, we generally call this concatenation rather than adding when talking about strings. Here is an example where we have two string variables that we concatenate together with a space between. The output in this case would be my name in the console window. Strings, like all data types, are based on a class. When we create a variable, we're instantiating an object based on the class. So when I create a string variable, I'm making an object based on the string class. Therefore, the string variable has properties and methods just like other objects. If you look up the documentation on the string class, you'll learn what properties and methods are available. One common used string property is length, to get the length of the string. In this example, I'm outputting the length of the string contained in the variable to the console window. In this case, the output would be 5, since there are 5 characters in Brian. Of course, we can output something a bit more user-friendly, as shown here, where the output would be 2 strings concatenated together with the length. In this case, it would say the string is 5 characters long. There are several methods available to work with strings. For example, there is a toUpper and toLower method, which converts the string into either all uppercase or all lowercase letters. There is a trim method that trims off any white space at the beginning or ending of a string, as shown here. There is also a trim start or trim end method if you want to trim off just one side or the other. And there's a replace method for replacing a substring within the string with something new. In this example, I'm replacing BR with JILL to make Jillian. These are just a few of the several string class methods. With Visual Studio, there's a feature called IntelliSense, which provides you with just-in-time documentation as you program. For example, here I just typed a period after the variable name, and the menu popped up with all the possible properties and methods for this variable, given that it was of type string. And here, when I rolled my mouse pointer over replace, it popped up a tooltip to describe what the replace method does and how it works. This feature really helps both beginner and experienced programmers alike. Let's continue our quick start into C# by talking about modifying the execution order of code through the use of conditionals and loops. In general, most programming languages run one line at a time in sequential order. So line 1 runs first, then line 2, then line 3, and so on. So code executes from top to bottom. You can think of code execution as steps the computer takes from one line to the next. At times, you may want the computer to not follow this step-by-step process. That is, you want the computer to jump forward or backward in the code. This is called branching or looping. Branching allows you to change the execution order based on some condition, such as user input, changes in the computer environment, such as time passing, or some other condition. A conditional is a logic expression that evaluates to true or false. Here are the common comparison operators that we use in C#, including equals to. Notice that it has 2 equal signs. A single equal is used for assignment, like setting a variable. But the double equals is for comparing if the left side of the operator is equivalent to the right side. If so, the conditional evaluates to true. If not, it evaluates to false. We also have not equals, greater than equal to, less than, and less than equal to. We can use these operators in our conditional statements. The most common form of branching can be done with an if statement. That is, if some condition evaluates to true, then instructions are run between the curly braces that precede the if statement. If not, these instructions are skipped over. In this example, the first if statement is checking if the temp variable is less than equal to 32. If so, it outputs it is freezing to the console. But in this case, the temp variable is not less than 32, since it's set to 40 above. Therefore, the first if condition evaluates to false, and we skip over it. The second if condition, however, evaluates to true, so wear a jacket is outputted to the console. Then the computer moves on to the third if statement. This condition evaluates to false, so the wear suntan lotion message is not outputted to the console. Else allows us to have an alternate section of code to run when the if condition evaluates to false. When we combine the if with the else statement, we can create more interesting branching logic. For example, here we set up several conditions to check for the temp variable. The logic is set up to evaluate the temp several times. If it evaluates to true, then the message is outputted to the console, and we're done. If, however, it evaluates to false, then the execution continues to the else statement. In the case of this example, where temp equals 100, all the if and else if statements will evaluate to false, so the final else statement will run. And wear a bathing suit will be outputted to the console. We can do more complex logic when we combine the and or operators. The and operator is represented as two ampersands in C#, and the or operator is represented as two vertical lines, or shift backslash on the keyboard 2 times. In this example, the first if statement checks to see if the temp is greater than equal to 50 and less than 65. Temp is set to 55, therefore both parts evaluate to true, and true is true. So the wear a sweater message is outputted to the console. The second if statement checks to see if the temp is greater than 90 or the weather equals sunny. The temp part evaluates to false, but the weather part evaluates to true. Since the or operator was used, the overall condition is true, and wear suntan lotion is outputted to the console. And we can use parentheses to build even more sophisticated logic, as demonstrated here. The parentheses in logical evaluation work just like they do in math operations to explicitly define the order of evaluation. In addition to if statements, the switch statement is another way to modify the order of execution. Here's an example of a switch statement. After the switch, you specify a variable that you want to check to see if it equals to any number of cases. Each case is defined within the body of the switch statement's curly braces. If a case evaluates to true, then the code that is after the colon and before the break is run. If none of the cases evaluate to true, then the code after the default is run. In the example here, where the weather variable is set to cloudy, the default will run, and dress for success will be outputted to the console. Another way to modify the order of execution of code is with loops. Loops are portions of code that repeat while a condition is met. There are 3 common types of loops. While loops continue while a condition is met, for loops, which typically loop for a certain number of times, and for each loops. Here is an example of a while loop. You can see we set up an integer variable called lives and set it equal to 3. Then we create our while loop. The code between the curly brackets will run through each time the condition is true. That is, while lives is greater than 0, the 2 lines below will continue to run or loop. So the first time through the loop, 3 greater than 0 evaluates to true. So lives 3 is outputted to the console. Then lives is decremented by 1. That is, lives equal lives minus 1. The second time through the loop, 2 is greater than 0, also evaluates to true. So lives colon 2 is outputted to the console. Then lives is decremented by 1 once again. The third time through the loop, 1 is greater than 0, also evaluates to true. So lives colon 1 is outputted to the console. Then lives is decremented by 1 once again. The fourth time through the loop, lives is now 0. 0 is not greater than 0, so the condition evaluates to false, and execution will continue after the while loop. Then, you are now dead is outputted to the console. The for loop is a bit more complex to set up. It contains an initialization, a condition, and an incrementer. Here's an example for loop. The initialization sets up the integer variable named power and sets the initial value to 1. The condition checks if the power is less than 3, which of course it is the first time because we just set it to 1. If the condition evaluates to true, then the code between the curly brackets is run. The first time through, power is 1 is outputted to the console. Then the incrementer happens. In this case, power is incremented by 1, so it goes from 1 to 2. Then we repeat the condition check again, and since power is still less than 3, we run the loop again, and output power is 2 to the console. Now power is incremented again, so it goes from 2 to 3. Then we check the condition again. This time 3 is not less than 3, so the loop is done. And line 4 would then be executed, outputting power up complete to the console. For loops are used often with arrays and lists. In this code example, in line 1, I create the family array that we created previously, setting it up with the 5 Simpson family names. The for loop is initialized with I equals 0. The condition is set up to continue to loop while I is less than the length of the family member array. And at the end of each loop, I will be incremented by 1. Therefore, this code would output each of the family members' names in the array starting at index 0, then 1, then 2, then 3, and finally index 4. Then I would equal 5, which is not less than the length of the family, and the code would continue to execute after the for loop. The for each loop is another loop type that is also helpful when you need to loop over arrays or lists. In this code example, in line 1, I create the family list that we created previously, setting it up with the 5 Simpson family names. The for each loop is set up in line 3. It basically says that I want to loop over each element in the family list, storing the element into the variable family name each time through the loop. Just like the previous example, this loop will output Homer, Marge, Bart, Lisa, and Maggie as it iterates over each element of the family list. In summary, the if and switch statements allow you to run certain code based on a logic condition, and the while, for, and for each statements allow you to loop over code based on logic conditions. Overall, these techniques allow you to modify the order of execution. Let's continue our quick start into C# by talking about functions and classes. While variables store information, functions take action. They do something, often based on some information provided to them. When you create a function, just like a variable, you give it a name. I like to use upper camel casing, sometimes called Pascal casing, when naming functions, where you capitalize the first letter of the first word, in addition to each subsequent word. This helps me distinguish between functions from variables, where I use lower camel casing. In addition to the function name, you also specify any arguments that you want to pass into the function. You can think of arguments as information that you want to give to the function for the function to perform its task. Arguments are specified between 2 parentheses after the function name. If you have a left paren and right paren with nothing between them, you are saying that there are no arguments. But if there are arguments, you would specify them between the parens and define them much like you define variables, using a type and variable name. In fact, when you define arguments, you actually are defining local variables that exist within the function. Those variables are set based on the values passed into the function when you call the function. More on that later. In addition to arguments, before the function name, you also specify a return type. That is, you specify the type of data the function returns back to whoever is calling it. This type can be an int, bool, string, or any of the same data types of variables. If the data type is set to void, as shown here, that means the function does not return any information. And you can also optionally set the access modifier of the function to things such as public or private, depending on how widely you want the function to be accessible. If the function is set to private, it will only be accessible within the class. That is, it can only be called within the class. If it's set to public, then you can call it from outside the class. As I said before, functions do things. You can think of a function as a named section of code that performs a specific task. You can specify what the function does between 2 curly braces that precedes the function declaration. You can see here I define a public function named add2 that accepts 2 integer arguments, x and y, and returns an integer. Within the body of the function, I created a new local variable of type integer named z and set it to the sum of x plus y, which are also 2 local variables of type integer that were set up as arguments. The code then returns the resulting integer value back to whoever called the function. You call the function by name and provide the necessary data to the function to do its job. A call to this function might look like this. Here I created an integer variable called player health and set it equal to the result of the add_to function, where I pass in the integer number 5 and 6. If this code ran, the next line would output the contents of player health to the console, which would be 11. Obviously, this is just a toy example, but it demonstrates several important programming concepts related to functions. Why do we create functions? Well, functions give you a mechanism to break a problem down into smaller parts. Each part of the problem is solved in a different function. Given that our code is compartmentalized into a function, it is easier to find problems and debug our code. Once a function has been created, tested, and we know it works, then we could reuse the function over and over. We don't have to duplicate code. This makes code more modular. Further, once we know a function works, we don't have to be as concerned with the details of the function. We call this concept abstraction in programming. We can treat the function as a black box that solves a problem. Classes have similar benefits of functions. One way to think of a class is as a container for a related group of variables or properties and functions or methods. Some of these properties and methods are public, represented in green, which means that they can be interfaced from outside the class. Others are private, represented in red, which means they are only accessible from within the class. That is, only code within the class can use them. We define a class by using the class keyword. Then following that, the class name. I like to use upper camel casing on my class name, just like function names. You can optionally include a base class that the class inherits from. In Unity, any class that we are attaching to a game object will inherit from the mono behavior base class. If you are making classes in general in C#, you may or may not inherit from other classes. Finally, just like variables and functions, we can define the access level of the class. If it's set to public, any other code can create instances of the class. For most of the scripts we write, we'll create public classes. Here is an example player class script, complete with class variables defined, which are also known as class properties, and class functions defined, which are also known as class methods. As you program in C#, you'll start to break down your game systems into classes, and within the classes, properties and methods. And before you know it, you'll be thinking in object-oriented methodology and dreaming in C# code. Let's conclude our discussion of programming in Unity by talking about some of the Unity-specific things you should understand. Overall, we say that Unity is an event-driven environment. You often add functions to your classes to respond to events that occur while the game is playing, such as start, which is called when the game object starts in the scene, and update, which is called every time through the game event loop. There are a few other events that happen when you start playing, including awake, unenable, and start in that order. These are great places to set up things, like initialize variables. During the game event loop, the update and late update events happen in that order. This is a great way to do things or check on things while the game is playing. And there are several other events that you can respond to, such as fixed update for updates that are synchronized with the physics engine, and events for collisions and triggers, as well as events for mouse input on game objects, such as mouse up and mouse down. And there are many other built-in events. And you can also create and respond to your own custom events as well. One common thing that we do in scripts is modify game objects in some way. When a script is attached to a game object, we can reference the game object in the script as this.gameObject, or just gameObject for short. For example, these two start functions do the exact same thing. They set the game object that the script is attached to inactive. This is the same thing as clicking the active-inactive checkbox in the inspector, except of course it is done dynamically at playtime. In this script, the name of the game object is outputted to the console window in the Unity editor twice. That is, both lines do the same thing. If we want to reference a game object that the script is not attached to, we can do this in a number of ways. We can have a public variable of type gameObject that we attach to another gameObject or prefab in the Unity editor. Or we can search for the gameObject using gameObject.find to search for a gameObject by name. Or we can search for the gameObject using gameObject.findWithTag to search for a gameObject with a particular tag. With both of the find techniques, you need to make sure that you only have one gameObject with a name or tag that you're searching for. Otherwise, you're not sure which gameObject you'll get a reference to. You can see in this example that once we have the reference to the gameObjects, we can call the setActive function in the same way. Once we have a reference to a gameObject, we often want to modify a component of that gameObject. Every property that you see in the Unity editor for a component can be referenced and often modified through code. For example, let's say we want to move a gameObject along the x-axis. We can do this through its transform. In code, we can reference the transform of a gameObject through the transform property of the gameObject, or gameObject.transform. The transform property has a position property, which in turn has an x property. So gameObject.transform.position.x is how we would reference or change the x position of a gameObject. We can do this in the update function so the gameObject moves every frame update. It turns out that the transform class has a built-in translate function that will essentially do the same thing. So alternatively, we could use that to move the gameObject along the x-axis. The function takes 3 arguments, one for x, one for y, and one for z. As you can see here, I'm only modifying the x. Not all components are properties of the gameObject, like transform. To get a reference to any component type on a gameObject, you can use the gameObject.getComponent function and then specify the type of the component. Once you do that, you can then manipulate the component. For example, this script gets a reference to the rigid body component attached to the gameObject and sets it to a variable named RB. It then modifies the useGravity variable, setting it to true or on. Another way to reference a component is to set up a public variable in your class. This will make the variable appear in the Unity Editor Inspector. You can then drag and drop a gameObject with the specified component to the variable in the inspector. Here are common component types that you might reference in code. Once you get a reference to the component, you can use the component's properties and methods to do things dynamically as the game plays. A lot of game coding is simply manipulating gameObjects and their components. When you're writing Unity scripts, the scripting API documentation that comes with Unity and is available on the web is an absolutely essential resource. You can use it to look up, for example, any component type and then find the properties and methods that allow you to work with the component through code. Another common thing that you want to do in code is to spawn or instantiate gameObjects into the game scene. This can be done, for example, to spawn enemies or create projectiles that the player fires. Here is an example script that instantiates a prefab. Once you attach this script to a gameObject, you could then set the prefab variable in the Unity editor to be the prefab that you want to spawn. While the game is playing, this code will run on each frame update. It checks to see if the user is pushing the fire button. If so, then it will get the current position and rotation of the gameObject that the script is attached to. Then it will instantiate a new gameObject based on the prefab at this position and rotation. There are ways to simplify this code, but I wrote it more verbose to hopefully help in understanding of the process. If some of the concepts we just discussed are very foreign to you, don't worry, you're learning a new language. Remember, it takes time and effort to get up that learning curve. Also, remember, Unity has excellent documentation. I recommend that you reference the online documentation often, especially the API scripting reference. Microsoft also maintains good online documentation on C# in general. Unity also has a vibrant community with a very active forum. If you have a question on how to do something, search the forums. Someone probably already has asked the question, and you can find an answer. If you cannot find an answer, you can always post your question to the forums, and someone will likely get back to you. Or just Google it. There are many great programming resources out there, such as Stack Overflow, which also has very active forums. There are also many great video tutorials on YouTube. Wow, we just did a rapid-fire quick start of programming in C# with Unity. I hope your mind is not too blown. This lecture should give you the base knowledge needed to understand the code walkthroughs that we will be doing across the rest of the course. I recommend working through your current class assignment and then coming back and watching this lecture again. Like learning any new language, it takes practice, experience, and some patience to get good at it. Once again, this is not really a programming course, but hopefully this and the projects that you'll be doing will help improve your programming chops. No matter what your role, programmer, artist, or designer, the more programming that you know, the better off you'll be when it comes to game development. Happy coding! Nice job! You got to the end of the first step in the game design and development specialization. You may be waiting for the final assessment of your project. If that's the case, please help out your fellow learners by doing as many peer reviews as you can of their projects. Not only will it help your fellow learners get through the course, you can actually get inspiration and learn a lot by looking at other people's work. And providing constructive feedback on others' work and learning to receive criticism on your own work are both very important skills to develop as game makers. As I said up front, making games is hard fun, and I do hope that you've been having a lot of fun and learning a lot as you work through this course. But this does not have to be the end of our journey together. This is actually just the beginning. I hope you'll continue on to the next course, where we will learn more about game development by building a 2D platformer game. We'll also discuss several game design concepts in more depth, such as the game world, storytelling, character design, gameplay, user experience, and game technology. In the meantime, I encourage you to continue to explore Unity and expand on the game you just built. Best wishes, and come back soon to continue your journey into game design and development.